I'd like to welcome you in this chapter where we're going to build our own visual types from C++ and use them in QML. We're going to start by painting on images and have something cool and visual to look at on the Qt Quick side. Next, we're going to show you how to draw a bar chart, all this using the QPainter API on the C++ side. And we're going to give our users an easy way to put data in our bar chart using these properties on the Qt Quick side. We're going to wrap up the chapter showing you how you can draw stuff completely from QML and show you that there is a possibility to do some complex stuff from Qt Quick as well. We're going to go in the next lecture and start doing this. In this lecture, we're going to create our own C++ visual types by painting on images. Here is what we want to do. On the Qt Quick side, you see that we have two images here. These are things we want to draw. You see we have a Qt one and we have another for Qt Quick. The Qt image is green and the Qt Quick image is blue. These are images that we are going to put in our resources, and we are going to paint on them and put these small rectangles you see on the bottom here. Our type is going to be exposed as logo, as you see on the left here. And there are a few things we can control from our types. For example, we can control the text we see in the bottom rectangle here. We can control the text color, and we can control the color of the background here. And we can also control what image we see, whether we see the Qt image here, which is green, or the Qt Quick image here, which is blue. And we control which image we see here by using an enum that we are going to put on the Qt C++ side. This is what we want to do, and we want our users to just be able to do logo and put a few properties inside the curly braces, and they're going to have their logo on the Qt Quick side very easily. So how do we do this? On C++, we're going to create a new class. The new class is going to inherit QQuick painted item. This is very important. This is the class that is going to give you the features you are going to use to paint and do some cool stuff. Inside, you see that we have regular properties, we have the colors, and if you look back to the API that we want to design, these are properties. Okay, we have the background color, we have the text color, we have the text we show in the small rectangle at the bottom, and we have the topic. Okay, the topic here is exposed as an enum that you see defined here, and we let the meta object compiler know that this is an enum that we would like to be visible on the Qt Quick side, and we expose that here using the QEnum macro. Another thing I would like you to pay attention to is that this is the method in which you are going to be doing your painting. If this doesn't make sense, you might want to go and visit the QPainter class. Actually, we're going to go to Qt Creator now and look at this together. Okay, here we are. We're going to go in the help and search for QPainter. And if you look in there, they're going to tell you this class performs low-level painting on widgets and other painting devices. So in this case, we are painting on an image. And if you look in the methods that they expose, they give you a lot of methods to paint things you might want to draw. I'm not going to go into too much details, but I want to show you that you can draw image, you can draw lines, you can draw picture, you can draw pixmap, you can draw points. You can really do all kinds of crazy things. And I think that if you scroll down, they're going to give you a bunch of examples of things you can do. If this is the first time you see this class, I advise you to go with me, do what I do, and you're going to really get a hang of it. And if you get stuck, you can always come to the documentation here and read about things you would like to understand more about. Okay, now you know a little bit about QPainter. How do we paint? Well, we go in the paint method. You see, the goal is to draw these things we see here on the right. The first thing we get the path to the image. We check to see which topic we are trying to draw. Remember, we have two topics. We have a Qt Quick topic and we have a Qt CPP topic. From our enums we defined here, you see Qt CPP and Qt Quick. So if we are drawing a Qt CPP image, we use this Learn Qt image, which is the default one. If we are trying to draw Qt Quick, we use the Learn Qt Quick PNG image. Once we have the path, we create a Q image that we are going to draw. We scale it to the width and height that we want for this class here. We grab the rectangle, the bounding rectangle really for the image, and then we draw in that rectangle, and what we draw is the scaled image. I hope this makes sense, and this is how you use the painter to draw an image. If you go in the documentation, you're going to see all about the draw image method here. Once we have drawn the image, on top of it, we are going to put this rectangle, and inside the rectangle, we're going to put a piece of text. How do we draw this rectangle? We set the brush, which is really the fill color. We get it from the properties. We draw a rectangle, and when we draw the rectangle, we need to specify a few things. We specify the top left point of the rectangle, which is this point here. The x coordinate of it is going to be the same at the starting point of this rectangle here, the rectangle that wraps around the image, and the y coordinate of it. This is very interesting. We're going to grab the y coordinate of the bottom left of the overall rectangle, and we're going to go up again a given distance. In this case, it is 33. We specify the width, which is going to be the width of the entire window here. And then we specify the height, which is going to be 33. We're going to go down again. I hope this makes sense. After we have this rectangle, we draw our text. We set the color of the pen to text color, which is our property that we can even specify from QML. We say that the position of the text is going to start at the bottom left of this rectangle, and then we move the text to the right by 10 and up by 10 so that it is a little bit in the center. We specify the font of the text, and then we draw the text by passing in the text position and the text that we want to draw, which we can also control from the Qt Quick API. I know this might not make sense yet if this is your first touch on QPainter, but we are going to go through this together, and you are going to understand after we have done a demo that we are about to do. Once you have your type, it really is the same thing we've been doing all along. You have to register it and use it in QML as you see here. Now that you have an idea about what we are about to do, we're going to go to Qt Creator and put this in action. Here we are in Qt Creator. We're going to create our project. It's going to be a Qt Quick application as usual. We're going to call it Paint on Image Demo, which is really what we're going to do. We save it in a location on our drive, hit next. Choose the Qt version you have installed. We want to use the desktop kit for this project. Let's finish. We want to create our class, which is going to be very easy to do. Let's call it Learn Qt Logo. That's what we want to create. Let's inherit Q object for now. We're going to change it in a minute. Let's go to the header, include Q Quick Painted Item, which is what we need for this to work. This is what we want. Let's copy it, inherit it here, and go down to the CPP implementation file and change the parent that we specified. Let's go back to the header. And before we do anything, I want to put in my resource files. I am going to go where the project is stored by clicking on main and choosing show in Explore. I am here. I am going to create an images folder and go inside. And I am going to paste in a few images that I had prepared before. You can see that we have the Learn Qt image and we have the Learn Qt Quick image. Let me open them so that you see what they are. You see it is an empty image. We have nothing on the bottom so that you see that the rectangle we're going to see down below here is going to be drawn from our code. And it is the same for the Qt Quick image. Now we can close this. Go back to our resource and say add existing files. We go in images and add them, and they should be now available here. Let's save the entire thing just to make sure. Next, we want to create our enum. It's going to be Qt topic. We are going to have two options inside. One is going to be Qt CPP, and the other is going to be Qt Quick. After we have this, we're going to expose this to Qt Quick by saying QEnum. We saw this before, and we are going to say Qt topic inside. Next, we want to make sure that this thing here is parented to a Q Quick item, because this should be part of the QML tree on the Qt Quick side. So we're going to use Q Quick item here. Let's choose this one and let's go down here, say QQuickItem, to make it completely usable in Qt. Let's go to the top and put in our properties down here. To save some time on typing, I have prepared all these properties. It really is nothing new. We have a color for the background color of the rectangle. We have a color for the text. We have the text that is going to be shown in the rectangle. And we have our enum that is going to specify which image we see in our Qt logo. I am going to put in my private section and generate the methods that we're going to need in here. First one, done. Second one, done. Third one, done. And number 4, we are done. We should go down here and figure out a way to move all these implementations to the CPP file. I am going to do this live as well so that you see everything. Let's go back, move to CPP. Move to CPP, this one. We move this to CPP. And the methods are done here. We should go to the getters and refactor, move to CPP, refactor. We do the same thing. We have 2 left, 1 left. And we should be all good by now, but we have some cleanup to do. You know, I don't like to have this as public slots. I am going to remove this and move it to the top and remove this. Control A, Control I to align, and our class should be completely set up right now. There is one thing we need to do. We need to provide the paint method, which is really the core of what we want to do here. So we are going to say void paint QPainter, and you see that Qt Creator is helping us here. Refactor, and we implement this. But before we do our painting, it is a good idea to initialize our stuff that we have in our class here. You see that we have a bunch of properties. We should really get in the habit of initializing our things. That way, we're not going to have much more surprises when we run our applications. We are going to initialize the background color here to white. Let's do that. We're going to say BG color and say Qt white. This is going to do. Let's look at the next one because my memory is not that good. The next one is text color. We're going to do text color. Let's make this Qt blue. Why not? We want to initialize the text. Let's say learn GUI. We just want to be able to see something in there. And the topic, let's say we want this to be QTCPP. This is going to do. Now we can come here and do our painting. The first thing we want to do is to draw the image. We're going to put together a QString that is going to store the image path. And we want to set this to something by default. It is going to be Learn Qt. Right click on the first image here and go down here where it says copy path. You want to copy this and put it in here. This is going to be the image we're going to have by default. And we are going to check to see mtopic equals to Qt quick. If it is equal to Qt quick, we are going to reset this image path to something else, which is going to be, let's put some space in here so that our things are readable. The path is this time going to be learnqtquick.png. We put that in here. And by now we should have our path. We go down here, create a QImage object. Let's call this image. We want to scale this image. We're going to say QImage scaled image equals image. We need to import QImage to be able to do these operations. So let's go to the top here and include it. Let's go down again in our paint method. And now we should have access to scaled. We want to scale it to the width of the window here and the height of the window here. And this reminds me that we didn't set the width and height. What I want to do, I want to specify a width and height that is going to be used by default. And I am going to use 128. And why do I do that? Let's go back to where our project is stored. I am going to go in the folder of my images. And if you look here, you see that my images are 128 to 128. You see the size here. So it makes sense to use that in Qt so that we have it displayed in a better way. We're going to say set width and set this to 128 and set height 128. And this is the width and height we are going to be retrieving here when we scale the image. We want to grab the bounding rectangle that wraps around the image. We're going to say image rect. This is going to give us the rectangle we want, and we can use the draw image method. If you go back to the documentation, I think we're going to actually see this. Let's go through the methods, and we have a method to draw image. We have a few overrides of this, and this is what we are going to be using. That takes a QRect, draw image, this one. You see that this is an overloaded function, draws the given image into the given rectangle. This is exactly what we're going to do. So we're going to say draw image, painter, draw, and we don't have QPainter included in here. This is a good time to include it. Let's try and put that in the CPP file here. QPainter. Let's go down here. And it's going to be available now. We want to pass mRectan, that's the rectangle we want to draw in, and we want to draw scaled image. We want to draw our next rectangle, which is at the bottom. We are going to say painter, draw rectangle. You see that it wants a few things. It wants X, Y, width and height. We're going to pass in the coordinates of the top left point to the rectangle, and then we're going to give the width and the height. The top left is going to have an X coordinate that is going to be the same as the coordinate of the bottom left of the rectangle. So we're going to say mrect bottom left X. The Y coordinate is going to be mrect bottom left Y, and we want to move up again by a given distance. Remember, in the slides we used 33. We want the width to be the width of the rectangle, and we want the height to be 33. What we really are doing here, I want to draw it so that it really makes sense. Let's pick a pen here and use the red color. We have the window here that represents our logo. What we want to specify is the top left corner of the rectangle here. Its X coordinate and its Y coordinate. Let's make the pen bigger so that you see its X coordinate and its Y coordinate here. The X coordinate is going to be the same as the coordinate of the bottom left corner of the rectangle, but the Y coordinate, we go all the way down and go up again a given distance, which is 33 in this second. That's why X is the same as the bottom left. Y is the Y of the bottom left minus 33, because the Y coordinate increases as you go down and it decreases as you go up. I hope this makes sense. Okay, now we have drawn our rectangle here. Remember that this rectangle should be filled, so we should set a brush to it. The brush is really the filling color for whatever it is you are drawing on your image here or on your paint device. So we're going to say painter, set brush, and the brush is going to be BG color that we specified in here. It's going to be by default white, but we can set this from Qt Quick because the BG color is also exposed as a Q property. Now we have our rectangle, and the next thing is to draw the text. I think we have a boo-boo here. We should close this and go down just like this. We want to set the color of the pen, so we're going to set pen. Pen is the color that you use to draw your thing. Let's see what we are using. It is going to be text color. Let's say text color, and we're going to read this from our properties. We want to set the starting position where we're going to start drawing our text. Let's capture that. Let's say txt pose. This is going to do. And we're going to say mrect bottom left. This will do. And we want to reset this a little bit. We're going to move the point up and right so that it moves a little bit in the center of the bottom rectangle that we drew. What I want you to notice is that this method returns a Q point. And Q point happens to have a few methods that can help us in changing the location of the point by specifying the amount of distance that we're going to move on the X coordinate and on the Y coordinate. Let's go back to the documentation and look for Q point. It's going to give you this class here. If you go down, you see that we have Rx and Ry. Let's look at this method. Returns a reference to the X coordinate of this point. Using a reference make it possible to directly manipulate X. For example, we can directly modify the position of the point, and this is what we want to do. So what we're going to do, we're going to add 10 to the coordinate of X to move it a little bit to the right, and subtract 10 to the coordinate of Y to move it a little bit upper. We're going to say txt pose Rx and add 10. This is going to do, and txt pose Ry, say minus 10. This is going to move this a little bit to the top. We want to set the font. We're going to say Painter because we want the font to be a little bit bigger. And I really don't remember these things. I'm not good at remembering these things. I am going to go to the documentation and search for Q font. And it's going to give me an example of what I can pass in there. I am going to copy all this actually and modify it. I am this lazy. I want to remove this. And this is going to give me something I can work with. I want to change this font to Consolas, and this should be okay for the font. Now we can actually draw the text. We're going to say Painter, draw text. The position is going to be txt pose, and the text is going to be text that we read from our properties. And if you look here, we have a text property, and the getter here is going to return the text that we draw in our method here. And ladies and gentlemen, we should have our type here drawing on top of the image that we passed in our resource files. We're going to go to main CPP, include our class. It's going to be learn Qt logo. We want to register it for using Qt Quick. You already know how to do this. This is the module name, major version, minor version, and this is what it is going to be available as in Qt Quick. Let's copy this and go back to our main QML file and include the module. Let's say import, put this in here, say 1.0. This is our version. And down here, we should be able to say logo, and it's going to be available. This is cool, isn't it? We can say the text. You see the text property is available. Let's say learn Qt. We can specify the BG color. Let's make this blue. We can specify the text color. Let's make this yellow. And based on what we set up in our constructor, it should show the QTCPP image, the green one, and show Qt Quick image when we have explicitly set the Qt Quick enum to be used in QML. Let's build this and see that we have no errors. Let's see what we messed up here. And we have a boo-boo here, a copy-paste error. Let's build again. Looks like we have a clean build. If we run, we expect to see the Learn Qt image, which is green. Let's fix this and run. And you see that we have our image here. The rectangle is blue because we specified the background color to be blue, and the text color is yellow. I don't know if you can see this, but it is yellow. Let's change it to red so that it is really visible on video here. And here we are. We are able to draw something from C++ and use the type in Qt Quick. And it really is nothing difficult. The only different thing here is the paint method that we are using to draw our stuff. Okay, we have a type here. What if we want to see another one that shows the Qt Quick image? It is really easy to do. Let's copy this and put another one down below it. Let's give this an ID, mlogo 1. The second one is going to be mlogo. It is going to be 2. It is going to be saying go fluid. The background color is going to be beige, and the color is going to be, let's do something dark. Let's say black. Why not? Let's go back to the CPP file and see what we exposed the topic as. The topic is going to be topic. How creative. Let's say topic. Here is going to be logo Qt Quick. Just like this. You access it through the logo class because that's the class that is wrapping around this enum here. We can run the application and we should see the Qt Quick logo wrapping around the other one because we didn't specify an anchor. Let's move it to the bottom of the first one. We're going to say anchors top equals mlogo 1 bottom. And let's specify margin anchors top margin, let's say 20, so that there is some kind of space between the two. If we run, we should see the two logos if everything is all right. And here we are. We are able to draw our types and control how they are drawn through the API that we have exposed to Qt Quick here. And ladies and gentlemen, this is really how you draw your own types from C++ and use them in Qt Quick. There's nothing special here. You just have to expose your type and draw whatever it is you want to draw through the paint method. And this API is pretty powerful. We have drawn something simple here, but you can draw some pretty complex shapes using this API. If you look in the documentation, all these things you see here can be drawn. You see, we can draw these things, you can draw arcs. You can really draw anything you want. The only limit is going to be your imagination. I encourage you to look into the documentation and see some things you can do. It is pretty exhaustive, and the documentation of Qt is pretty easy to understand. I am sure if you want to draw something I haven't even talked about in the course, you're going to find your way by sifting through the documentation here. We're going to stop here in this lecture. In the next one, I am going to show you how you can draw a bar chart and provide some cool APIs users can use to draw bar charts very easily from Qt Quick. I'll see you in the next lecture. In this lecture, we are going to take our game to the next level in using QPainter to draw our own C++ types and use them in Qt Quick. We're going to draw a bar chart. What we're going to draw looks like this. You see this thing on the bottom here is a bar chart. The first thing I want you to know is that this is not real data. It is just some dummy data that I put in for us to have something nice to look at. Down below here, this is what we're going to have when we run the app, and the API should be usable just like this. The user should be able to say stir chart in QML and specify some properties, and they are going to see the chart like this in QML. So how are we going to build this? You must have some ideas based on what we did in the last lecture. We are going to create a class, and the class is going to have a paint method. And inside the paint method is where we are going to do our own drawing. The real problem here is really to figure out how to draw everything you see here, because we are going to draw all that. We're going to draw the bounding rectangle here. We're going to draw all these numbers you see here and these bars below them. We are going to draw all these rectangles in the middle and these country names in black that you see. And now it might sound challenging, but we are going to go through the process of how we do that, and you are going to understand and hopefully be able to do even more complex stuff by yourself, taking reference to the documentation that Qt has to offer. Our paint method is going to look like this. We're going to draw the border or the bounding rectangle. We're going to draw the text that you're going to see on the top. We're going to draw the stairs. And we're going to expose this as another function that we can call easily to have some cool API you can look at. For example, if you look here, you see that we are drawing one bar in our bar chart. And at least it is going to be very readable to the user who looks at your source code. In next lecture, we're going to be able to expose this to QML and be able to specify the stairs here using list properties, but we're not there yet. We're going to get there. Right now, we just want to be able to have a chart that we can look at. And at the end, we are going to draw the scales so that the user can know the meaning of the data that we have in the chart. Okay, this is what we are up against in this lecture. We are going to go to Qt Creator and build this. Here we are in Qt Creator. We are going to create our project as usual. It's going to be a Qt Quick application. It's going to be called Bar Chart Demo. Save it in the usual location. Hit Next. Choose the Qt version you want to use. Choose the kit, which is desktop in this case here. And we finish. We are going to add our new class, which is going to be called Stair Chart. It's going to inherit Q object by default here. We are going to change this in a minute. Hit Next and finish. Let's go to the top. We want to include Q Quick painted item, and we want to inherit the same class, Q Quick painted item. Let's copy it, put it here so that it is the class that we inherit. We also want to say the same in the CPP file, and the parent class is going to be Q Quick item. This will be taken care of here. Let's actually copy the class here, go to the CPP file and put that in here. This is taken care of. We want to provide our paint method. We don't need to do anything complicated in here, and it's going to take a QPainter pointer painter. We want to implement this in the CPP file. And to have something to look at, we first want to go to main and include the class. And go down here and expose it as a type that we can use in Qt Quick. Control-A, Control-I to align. It is going to be available as stair chart. We can copy this. Let's copy, move to the Qt Quick side and import the module. We don't have this module yet working, but we just want to be able to run things as we are building this, because I want you to see things as we build them one by one. Let's go back to our CPP file for the stair chart class. The first thing we want to do is to grab the bounding rectangle that wraps around what we want to draw. It's going to be mrect. The x coordinate is going to be 0, y is going to be 0. The width is going to be the width of the rectangle here, and the height is going to be the height of the rectangle here. We want to draw the border. We want to provide a pen that we are going to use to draw the border. Let's call this pen. Let's set the color of the pen. We should include this in the include section here. So let's do that. Include QPen and include QBrush. If you don't know these classes, you can look them up in the documentation by selecting one and going to F1. You're going to have all the information in here, and you can expand this by clicking here to see the entire thing in full help mode. The pen class defines how a painter should draw lines and outlines. Let's go back to the code, and the brush class shows the filling of the shape that you draw. Define the fill pattern used for shapes drawn by QPainter. You can read all about the class here if you are interested. We're going to go back to our code and get these things done. We want to set color for the pen. Let's make it red so that you see it first. We want to set also the width of the pen, set width. We want to make this 4, for example. We want to say painter, set pen, and QPainter is not included, so we should put that in here. And this is going to be recognizable now. We want to pass in mpen, and after this we say painter, draw rect, to draw the bounding rectangle. Let's say this, and right now we should come to the top here and give this stair chart a width and a height that we can look at. For now, let's say set width and say 400, and the height we say 400. This is going to do for now. The border of the rectangle should be red because that's what we set here, and its width should be 4. So now, because we exposed our type in main CPP here, we should be able to come to QML, and notice we have the import here. We should be able to say stair chart, and it should be available here. Let's build the application to see that we have no boo-boos. Let's look at the build process of this thing here. The build is clean and cool. Let's run the application, and you see that we have our rectangle here that is red. This is wrapping around everything we are going to have in the chart. This is the first step, and it is out of the way now. Let's go back to stair chart CPP. Let's go down here. I am going to open Painter again and try to explain what we are going to draw. So what we have is a rectangle like this that wraps around our chart, and we want to be able to put in charts like this. Okay, so we want to have something like this, for example, and another one like this, and things like that. So what we want to define is the starting position where we want to draw, the width of what we want to draw, the height of what we want to draw, and the fill color inside. So the X position is going to be in regards to the starting point of this one. So we are going to use the bottom left of the rectangle as the starting point, and we are going to be adding to the X coordinate of it to find the X positions where we want to draw. And the Y position, which is the height of the bar, we are going to subtract from the bottom left Y coordinate, and then add to that again to draw that height. It is exactly the same thing we did in the last lecture, but here we are going to be doing it all over again. I hope this makes sense. Let's go to Qt Creator and keep doing this. But before I draw, I want to set my pen and my brush so that the bar is going to be filled with that color. I want to set this to yellow so that you have something to look at. I am going to say Painter, set brush, the fill color, it's going to be Q brush. And inside we're going to have a Qt yellow color. We also want to set the pen, Painter, set pen, and I am going to say Qt yellow, the same thing. You can set the pen like this. Now I want to draw the first bar. I am going to say Painter, draw rect. I want to start at a distance of 50 from the bottom left of the rectangle. So I am going to say mrect, bottom left, x plus 50. The Y position of the top left of the rectangle is going to be the height of the rectangle minus the value of the bar chart. So we're going to say mrect, bottom left, Y minus the value that we want to draw for the bar. Let's say we want to draw 200 because the height is 400 here. So 200 is going to be in the range because we want to have our bars have a width of 50. So the width should be 50 here, and the height should be the value that we subtracted here because we want to draw that towards down the bottom left of the rectangle. I really hope this makes sense. So we're going to put in 200 here. If you run the application, we should say this. Let's run and try to explain again. You see, the first thing that we want to specify when we want to draw a rectangle is the top left of it. So this is the point that we want to specify. Its X coordinate is going to be the bottom left plus 50, which is going to be here. Its Y coordinate is going to be the bottom left of the a rectangle here and minus the height that we want this rectangle to have. So its width is going to be 50, which is what we specify here. Its height is going to be whatever we subtracted when we wanted to specify the top left of the rectangle. This is one way I chose to draw this. You could choose whatever reference you want. I chose the bottom left, but you could have easily chosen top left here, top right, or bottom right like this. Any of these points would have worked in the same way. Now we have our first bar. We can really easily put in other bars. So for example, I can copy this and paste it here. The only thing you really have to be careful about is where you start to draw, because this one started at 50 and it has a width of 50. So to have these bars next to each other, this time I should start at 100. And I should change the color of the pen and the brush so that I have another color. For example, I am going to make this red now, and this is going to be red. If I run the application, I should have a second bar, but they should be the same height. After we run, I am going to change the height of the second one to 150. Why not? And 150 here. And run again. And here is our bar. Now we want to refactor this into a method that we can call to draw for us without doing all these things in here, because this is very repetitive and it is not maintainable. So what I'm going to do, we can actually let Qt Creator help us here. I am going to refactor this. Let's see that this works. We're going to say draw rect. This is going to be private. If I say okay, let's see what we have. We have draw rect. We have the painter. We have the rect. Let's go to the header and find this method. I want to take this method and move it to the private section down below. We want to add a few parameters to this method here. For example, we want it to also take the color and the value of the bar. This is going to be QReal value. Let's say bar value so that it is descriptive. We also want to specify the starting point where we want to draw on the x-axis. This is going to make this a little bit better. We're going to say int starting point. We want to go to the implementation file and update the signature of the method. We copy these things that we just added, and we're going to put them right here. So inside here, we want to update to use the information that we have in here. The first thing is to set the pen. So painter set pen M color, because this is the color we want to use. Painter set brush Q brush, and we pass in M color. This is going to do. Now we can actually draw. The starting point is going to be this one. So we want to add the starting point here. And the value is going to be this one. So we should subtract bar value here and specify the height to be bar value also the same way. So we should be able now to come to the paint method and comment all this out and specify the values that we want to pass in. So it is color, value, and starting point. So we should say color Qt red. The value is going to be 200 as we had before. The starting point is going to be 50. And if we run, we should see the same thing we saw before, except that we are going to have only one bar. This is going to prove that our method is actually working. And we have the bar here. We can put in a second one simply by copying the method here and saying the color is going to be blue, for example, and the value is going to be 120. Why not? And we are going to start at 100. And if we do that, we should have a second bar. The second bar is here, and this is much more readable in the source code here. Next, we want to put in the scaling so that the user knows the value that we see in here. For example, you need to know what this value here stands for. We want to put in the scaling so that the user sees easily the values of these things here. Let's go back and try to draw that. And then after we draw that, we're also going to extract that in a function so that it is easily doable like we are doing in this method here. I actually think that we shouldn't call this method drawRect. It is misleading because this is a method that is available in the QPainter API, and we are really not drawing a rectangle. In our case, we are drawing a stair in the stair chart. So let's call this drawStair. We're going to click on it, right click, refactor, rename the function to draw, and it is going to be updated in the files that you see in here. Let's hit enter, and we should have our function updated. And if we run, we should see the same thing we saw before. Okay, this is our thing. Let's try to draw the scales. Let's go down here. The first thing we want to do is to set up our pen. It is going to be black and have a width of 2. And we want to set the painter to use the pen that we specify in here. We're going to say mpen. And I noticed that we are redefining this, and it was defined in here. So I am going to remove this line here. I want to draw the first bar, which is going to be on the y coordinate. It is going to be a line that starts to the bottom left of the rectangle and move to the right on the x coordinate by 20. And I achieved this by adding points to the point that I had before. The first point was the bottom left, and I am adding 0, 0 to stay there, and I am adding 20, 0 to move a distance of 20 on the x-axis. Let's run this so that you see what this looks like. It really is nothing complicated. We are just taking 2 points and turning them into a line. And you see the line here. I don't know if you can see it, but it is here. We want to draw our scale in increments of hundreds. So the second one is going to move up by 100, and we are simply going to subtract 100 from what we had before. And you see it is the same thing here. Let's run. You see the second scale here, and we are going to do the same for 200 and 300. Let's copy this and paste this a couple of times. Let's actually close this so that we see the entire thing here. Control A, Control I to align, and I want to move this to the next line. This is going to be 200 here, 200, and this is going to be 300, 300 here. If we run, we are going to see the scale for 0, 100, 200, and 300. And this is what we have here. And it should be nice to also have numbers specifying what we have in here. I am going to close this, come back to our code. I am going to draw my first text for the first scale point. Just like this, we are drawing some text. It is going to start to the bottom left point, and we are going to move 3 in x coordinates and move -10 from the y coordinate. And what we are going to draw is 0. I want to run this so that you see what it looks like. And this is what we have here. We have a 0 text. It has moved 3 on x and -10 on the y axis, and that's why it moved up a little bit. We are going to do the same for the others. It really is the same thing. We are going to copy, put it here. This is going to say 100 because that's the scale we are at. And the challenge is going to know what we are going to subtract here. And it should really be this +10. So we are going to subtract 110 here. We're going to copy the same thing so that we save on time. I am going to say 210, and this is going to say 200. I am going to paste again here. This is going to say 310, and this is going to be 300. We should have our scale in place now. Let's run the application and see what we have. 0, 100, 200, 300. This is nice. And if you want to move this to its separate function, we can actually copy all this and move to its own function, refactor extract function. It's going to be draw scale, and it's going to be private. And if we hit OK, it should be now gone to its own function, draw scale, and it is specifying the painter, the pen, and the rect. We really don't need to specify the pen here because it's always going to be black. So let's create a QPen object, QPen, pen. This is going to do. Let's remove the pen here when we call the method. What is wrong here? In the header, we didn't change what we just changed in here. So let's go there and change it. Build the application to see that we have exactly the same thing. Let's run. And this is what we have here. We should now figure out a way to put the text in here. It is really going to be easy because it is just drawing the text. And the challenge here is figuring out where you start drawing. We are going to go a distance here from the top left of the rectangle. I am going to go in the paint method here. And before we draw anything, I am going to put in my code to draw the text. And you see that it really is nothing complicated. We are just taking the top left point, which is going to be our starting point, and we add a distance to move the text a little bit inside the rectangle. Let's run the application, and it is going to use a default pen and brush, and you see what we have in here. And this is really what we set out to do in the lecture. But to make it a little more appealing, I am going to put in a bunch of other bars. This is going to start at 150. This is going to start at 200. This is going to start at 250. Let's do that. And this is going to start at 300. The value is going to be for this, let's say 300. Why not? This is going to be 50. This is going to be 350. And this is going to be 100. Let's shuffle the colors here. Let's say yellow, let's say black, let's say green, and let's leave the last one to be blue. This is really not important. I just want you to see a better bar than what we had before. And this is beautiful, isn't it? Okay, this is all we set out to do in this lecture. We have our bar here. And again, the bulk of this is really knowing what to do in the paint method. And I hope this really opens your eyes on what kind of things you can do inside this paint method. In the next lecture, we're going to allow the user to put in these bars that we are putting in here by drawing stair, and let the user be able to specify the stairs in here and put in the properties that they want using list properties. I'll see you in the next lecture. In this lecture, we are going to improve our bar chart that we had in the last lecture and make it usable with list properties. The QML API we want looks like this. We are going to have a stair chart inside, and inside we can specify the stairs like this. We can specify the starting position, which is the from property here, the value, which is the value of the bar, the color, and the text that is going to be shown inside of the country, which we are representing in this stair. You already have an idea of how to do this. We have to use QML list properties and provide a bunch of callbacks that the QML engine is going to call to transform what we have here in a list that we can store in C++ and manipulate. This is the chart we are going to have by the end of this lecture. You can see that visually, we also have a few improvements. We have the background color, we have the country name, and we have a little white rectangle in the background of the text here to kind of make this presentable. So how do we do this? We're going to create another class which is going to represent our stair, and it's going to expose the properties that we want to use in QML. We're going to have a color property for the color of the stair, the value, the text that we want to show inside, and the starting position, which is the from property in here. It's going to be an integer. We are also going to use the stair chart type that we had in the last lecture, but it is going to expose a list of stairs wrapped inside the QML list property like this. And we're going to wrap around this list here. You see, it is a list of stair pointers. The stairs property here is going to return a QML list property that wraps around the methods that we are going to use to manipulate the list by the QML engine. And you see here, we only have one method. The others are going to be null because we really are not interested in them. And down below here, you see the implementation of the append stair method. It really is doing nothing special. We are just taking the list object here, transforming this into a stair chart, and using it to add the stair that we have in the other parameter. And we are parenting this stair here to the chart, which is really this object here. And we emit the signal to say that the list of stairs has changed. Okay, this is going to take care of building the list on the C++ side of our application. How do we get to draw the stairs? Well, the paint method is not going to do anything special. It is going to just loop through the list that we have of stairs, and it's going to grab a bunch of properties from the stairs to set up our painter. You see here we are setting the pen color and the brush color, and then we are drawing the stair, which is really what we've been doing all along. We are capturing the bottom left point and setting the X coordinate. You see that we are adding the from or the starting position here. We grab the value. We set the Y coordinate to be the Y coordinate of the bottom left, and we are subtracting the value, and we are specifying the width and the height of our rectangle. The rectangle here is going to be stored in this object, which is called stair rect, and we want to draw it. After we do that, we set the color of the pen and the brush to be white. We draw the white rectangle, and we draw it based on the top left corner of the stair rect. It is going to be moved to the right and down a little bit by a 10 distance like this, and it is going to be 25 wide and 25 high. We then set the font and the color, and we draw the text on top of the white rectangle that we just drew here. I know this might look complicated, but it really is easy. It is the same thing we've been doing before. The only thing that is special here is that we are grabbing the list of stairs from the QML side and storing them on C++. And when the paint method gets to be called, our list is going to be already built, and we are going to draw everything in here. Once we have everything defined, we just register stair chart and stair, and we use that on the QML side. We're going to go to Qt Creator and build this. Okay, here we are in Qt Creator. We are going to create a new project separate from the last lecture so that you have an easy way to go to whatever project you want. I'm going to hit new. It's going to be an application, a Qt quick one. We're going to call it bar chart list property demo. Save it in a location on our drive, hit next. Choose the Qt version you have installed. Choose the kit you want to use and finish. And because we don't want to build everything from scratch, we want to start from the last lecture. We want to go to main CPP here, right click, show in Explorer. It's going to take us where this project here is stored. And you can see that it is in the last lecture. The entire path is this one. I am going to copy everything in here, the two main files and the stair chart class. Copy this, close this, and close the last project. I actually also want to close this. Let's go to the main CPP, show in Explorer. We have the location here, and we put in everything we just copied from the last lecture. We override the files, close this, and if we go inside, we should have the new main file in here. Let's add the existing files and put in our stair chart class. We want to add the stair class because we're going to need it. So add new CPP class. We call this stair. It's going to inherit Q object. Nothing special here. We go to the header and put in the properties that we are going to use here. Control A, Control I to align. You see we have the color, the value, the text that is going to be shown in the stair or the bar, and the starting position, which is called from here. Let's go down here and put in our private section down below. This is where I like it. I am going to put in the methods that are going to make these properties work. Refactor, generate the methods, refactor, generate methods, refactor, generate methods, refactor, and generate the methods we need. And we are going to have our fields here. We should move these methods to the CPP file. Let's do this pretty quick. Move to CPP. We are moving the setters right now. Set value, move to CPP. And set color, move to CPP. Let's move the getters from, move to CPP. Text, we move the implementation to CPP. Value, we do the same. And the last one is going to be color, and we move to CPP as well. We want to do some cleanup next, and it's going to be about moving these slots into the public section of the class. Remove this thing here, we don't need it. Control A, Control I to align, and we have our stairs class. Let's go back to the stair chart class. We are also going to put in a bunch of properties, Control A, Control I to align. If you look in here, it is a QML list property that is wrapping around stair class. We actually have to import this, so I am going to include like this. We have a title that is going to be shown in the top of the chart, and we have the background color, which is a new property that we are introducing right now. We should generate the methods we're going to need, and we do that for the other properties as well. And we should go down here and notice what we have. I am going to move the methods to the CPP file, the implementations of the methods, I should say. Let's move set title to the CPP file, move the getters, do the same, and title, refactor. Let's go to the header again and move stairs to the implementation. But before I do that, I don't want this to be constant because it is going to be used to modify this list here, so it shouldn't be constant. Let's move the implementation to the CPP file, and we should be fine by now. The other methods are fine, but the stairs method needs to return a QML list property that wraps around a bunch of methods that are going to be used to manipulate this list. You must remember this from a few lectures that we did before. We are going to say return QML list property. It's going to wrap around stair. It's going to take the first two, these pointers. It's going to say pound symbol, stair chart, and it's going to say append stair. This is the method we're going to need. And the other three methods are going to be null pointers because we're not going to provide them. Let's do that. And this should be fine by now. We need to provide this method. Let's go to the header, go in the private section. If you remember, this is where we put these kinds of methods. We are going to say static void append stair. It's going to take QML list property stair pointer list, and it's going to take a stair pointer. Let's call this stair. We should actually move this pointer to the outside of this thing. Sorry for the typo here. We should implement this method. We are going to grab a stair chart pointer from the list pointer that we have here. The way we do that, we say stair chart pointer chart equals Q object cast and we want to cast to stair chart pointer, and what we want to cast is list data. We have done this before, if you remember, and we say if chart, if we actually were successful in casting this to a stair chart, we are going to reparent the stair here to the chart. We're going to say stair set parent chart. This is going to take care of memory management. Whenever this chart here is going to die, it is going to take care of managing the memory of these stairs that are its children. We want to add the stair to the list of stairs that we have in here. We should say chart stairs append stair. And if you remember, this list here is storing a list of stair pointers. Let's go to the header and verify this. And if you look here, we actually forgot to change this. I am glad we found this. So we're going to say QList and say stair pointer. This is the list we have in here, and this is going to work now. Let's see that stairs append stair. And after we do this, we should emit this signal here saying that stairs changed. We actually don't need this parameter because we're not going to use it to do anything. So we are just going to say chart stairs changed. And this is going to notify whoever is interested in this stair chart object that its list has changed. And this should really take care of adding stair objects from QML when we are using a list property API. Now we should really have everything in place. The only remaining thing is to provide a default property so that we don't need to specify the stairs property when we put stair objects in our QML file here. Let's go to the header here again and put in our class info macro to specify that this property here is going to be our default property. Now we have all the properties that we need for this to work. The only thing that is remaining is the most important thing, which is modifying the paint method. So it is not going to draw hard-coded things like this. It is going to draw the stairs that are coming from the list that we had. So we can actually safely remove everything inside here. But before we remove it, we should actually comment this out. And we're going to remove it after our code is working. So what we can do here is do a for loop to loop through the entire thing. Let's say I equals 0, I less than the size of the list, and increase. We're going to capture the stair that we want to work with. Pointer stair equals stairs at the index I. This should be all we need to do to get the stair here. We are going to set the pen and the brush, Control A, Control I to align. We put together the rectangle that is going to be our bar. We capture the bottom left corner of the rectangle. That is the bounding rectangle for the entire chart. And we start from there. We add the starting position of the chart. We put in the value. We subtract the value from the y coordinate of the bottom left, which is really what we've been doing all along. And then we specify the width of the chart, which is still going to be 50. And we specify the height of the bar. This is going to give us the rectangle that we want to draw. We are going to draw it. Painter, draw rect, stair, rect. This is what we want now. We set all the colors to white, Control A, Control I, because we are now about to draw the white rectangle that is going to be in the background of the text inside the bar. We draw the rectangle, Control A, Control I to align. It really is nothing fancy. We start from the top left of that rectangle and we move to the right on X and move to the bottom on Y and specify the width and the height. And what really remains is to draw the text which is going to be on top of this rectangle. We set up the pen and the font before we draw the text, and then we draw the text, and it is really going to be to the top left of the stair rect, and we adjust by adding 15 to X and 15 to Y, which is really going to move things a little bit to the right and to the bottom, and then we draw the text that is stored in the stair objects that we captured here. After the loop here, we are going to draw the scale, and we are going to do it in exactly the same way we did it before, but this time we want to set the font to be a little bit bigger before we do that. And in this lecture, I want to take a chance to show you that whenever you modify the painter like this with a bunch of properties, it is a good idea to do painter, save, before you do any drawing. And before you return from this method, you should do a painter, restore, so that other widgets that are interested in using the painter are not really disturbed by the settings you do in here. So the painter is going to come in undisturbed. You are going to save it. You are going to modify it as you want to suit your needs. But before you get out of this method, you should restore it so that other people are not disturbed by your changes in here. I hope this makes sense. Okay, this is really all we need to do to draw our stairs that are coming from QML. Again, this list here that we are drawing is being built by the append method, which is here. And it is called by the QML engine because we exposed it here in the QML list property that we returned. What remains now is to go to main, include the stair class. Let's do that. Stair, register the type of stair. We're going to copy this and change what we need to change. This is going to be stair. And in here, it's going to say stair. And the module is going to be the same as we had before. We can build now. And you see that we have this error here. What is it? It is saying no matching function call to QObjectCast void pointer. And what we have here is that we use data here while we should use object, because it is the first pointer that we specified in here that we want to capture and cast it to a stair chart object. If you are not clear about what we are doing here, you should check the documentation for QML list property here. Select it, hit F1. You are going to go to the documentation for it. And if you scroll down, you're going to see that this is what we really are doing here. The first pointer is this QObject pointer. And they say that the list property remains valid while objects exist. Whenever this object pointer that you pass in here is alive, the list property is going to be alive. But the point here is that we can cast this to a stair chart object because what we passed in was a stair chart pointer. So we can cast it back. It is the first pointer we passed in here. We can read it like this and cast it to a stair chart, and it is going to work. We're going to build again. And you see that we are building without a problem. We should go back to main and see that everything is there. Let's go back to main QML and put a bunch of properties inside this stair chart of ours. I have a few properties prepared to save you some time. I am going to just put them in here, Control A, Control I to align. And I don't know why the title is not being recognized. Let's go back to stair chart and see that we actually have title here. And we really do. So this must be Qt Creator playing games with us again. Let's clean the project, build it again, and run and see what we get. And you see that we have our chart here as we would have wanted, but the title we see here is not the title we have drawn, and the background is not being shown here because we didn't do that in stair chart CPP. So let's find where we are drawing our thing. And it turns out that we forgot to draw the bounding rectangle, Control A, Control I to align. we set up the pen that we are going to use, and we set the pen and the brush. The pen is going to be the pen that we specify here, and it's going to be gray, but the brush is going to be the background color from the properties that we exposed here. This is going to be this one. So right now we should draw the rectangle, and all we have to do is say painter, draw rect, and say I'm rect. And hopefully if we run the application now, we are going to see our background color, and it is here. This is exactly what we want. And the title that we are showing here is not the title that we specified in here. You see, we are saying wheat consumption, but here it is saying carbon emissions. So we should use the title that we pass in our properties here, rather than say something hard-coded in. What we're going to do is say title, and this is the method that is going to return the title that we set in QML. And if we run, we're going to see our thing. It's going to say wheat, and this is what we have here. And you should really ignore these errors. It is Qt Creator trying to play games with us. Our design is exactly working the way we want it. Okay, we are using the list properties that we defined here. And you should note that this is just a syntactic sugar. You can still use the list properties in their normal way, Control A, Control I to align, and pass in a list and assign it to the stairs property that we have in our stair chart here, which is this one. And it is going to work exactly the same. And when we run this, we should see more bars in our bar chart. Okay, this is what we have here. And you see that it is really complete with data that you can see inside here. This is really all we set out to do in this lecture. We have a clean API that our users can use to construct their own bar charts. All they have to do is define a stair chart component here, put in a bunch of properties, and they can put in whatever they want in here to display. And the difference between this and the last lecture is really that we are putting in this QML list property here and putting in all the plumbing that is necessary for this to work. We are putting in this stairs method, which returns a QML list property that allows us to manipulate the list that we have in here and build a bridge between QML and C++. I hope this was informative to you. In the next lecture, we're going to see how you can draw things like this completely in QML if you happen to need that. I'll see you in the next lecture. In the last few lectures, we just saw that you can draw pretty complex shapes using the QPainter API from C++. In this one, I want to bring to your attention that there is a way you can also draw complex stuff in QML if that's what you want. This can come in handy if your team is really lacking in C++ skills, or for whatever reason you don't want to touch C++. This is really going to come in handy. The way it works, we are going to use the Canvas API. The Canvas API in QML is really borrowed from the JavaScript standard, in which we also have a Canvas component that we can use to draw shapes in the browsers. And QML provides a similar API under the JavaScript engine that is running in your QML engine. Practically, you're going to have a Canvas component, and it is going to retrieve a context 2D that you are going to use to draw on the canvas. For example, to draw the shape here, we are going to retrieve the context 2D from the canvas, and then we are going to call a few methods to draw the arc. The method to draw the arc that we are going to use is really documented here. The first two parameters are the center of the arc that you are drawing. You pass in the radius, you pass in the start angle, the end angle, and the direction of your drawing, whether it is clockwise or anti-clockwise. And this is really how it works. You have a few shapes to look at here to make it a little bit clear. We are not going to say too much about the Canvas API. It is complex in itself, and it really needs more time that we can have in this course. What we're going to do, we're going to go to Qt Creator and show you a small example of drawing something, and hopefully make you aware of the capabilities that you can do with this completely from QML. Let's go to Qt Creator and do that. Here we are in Qt Creator. We are going to create our QML project. It's going to be a Qt Quick application again. We're going to call it QML Canvas Demo. Hit next. Choose the Qt version you want to use. Choose the kit you want to use. We're going to choose the desktop one here. And we're going to finish. We are going to create a new QML file inside this QML QRC here. So add new Qt QML file, Qt Quick 2. Let's call this circle because it is a shape of a circle that we want to draw. And we have the item here. Let's modify it to use Qt Quick 2.11 because that's the latest version as of now. Inside, we want to put a canvas component. And you see that it is recognized here. And you can read more about it by clicking on F1. And it's going to open the documentation for it, and you can read about it, really. The canvas item allows to draw all kinds of shapes, and the rendering of the canvas is done using the context 2D object. This is our chief weapon here that is going to provide the methods that we can use to draw, and you can see that there is quite a bunch of methods that we can use here. Let's go back to our code in QML. Let's specify the ID for this. Let's call it root. We give it a width of 300 and a height of 300. Our drawing is going to happen in the onPaint method. We want to go inside and do our drawing. We want to define a variable that is going to represent our context. And we are going to call getContext and pass in 2D because that's the context we want. And after we get it, we want to reset it. Let's do context here. Reset. This is going to reset our context and make it ready to be used to draw our thing. We want to define the center point that we are going to use to start drawing. Let's say var center x. It's going to be width divided by 2, and var center h is going to be height divided by 2. And we want to begin drawing. We are going to say context begin path. We want to specify the fill color that we are going to use to draw our shape. We are going to say context. The way you say that, you say fill style. And it's going to be equal to yellow, green. And we want to move the pen that we are using to draw to the center. We're going to say context, move to, and pass in center, X, and center, Y. We should actually make this a Y, not an H. And we want to draw our arc. Remember, we are trying to draw the shape we saw in the slides. We're going to say context and put in our code to draw the arc. This is going to say center X and center Y. I made a typo here, but I am keeping it here because I don't want to retypo this. This is the center point. The radius is going to be the width that we have and divided by 2, so it is going to be 150. We want to draw the arc starting from 0, and we are going to get to 270 degrees. And if you look to the documentation again, let's go there and look at the arc method. This is going to be anti-clockwise. If it is true, we are going to draw anti-clockwise. If it is false, we are going to draw clockwise. We have it false here, so we are going to draw clockwise. After we have done our drawing, we want to move the pen back to the starting point. So we are going to say context, line 2, and put in center X and center Y. The exact same thing we did here. Let's put in our semicolon. And the last thing we want to say is context fill to draw our thing here. Okay, this is what we need to have something drawn on the canvas. I want to go to the main QML file and put in a circle here, just like this. And the type is going to be available. You must know this from the basic QML knowledge. Let's run this and see what we get. We are drawing from 0 and we are going 270 degrees and stopping here. And notice that we are going clockwise because that's what we specified in here. What we are doing here is really beginning drawing. We are specifying the color that we are going to fill our shape with. We are moving to the center where we are going to start drawing. We are drawing an arc that is going to start from 0, which is this location here, and it's going to end at this location here. This is the final angle, which is what we specify here, math pi multiplied by 1.5. The radius is going to be width by 2, and it is going to be this thing here, and it is clockwise. These are the things we can specify, and you draw by calling context fill here. There are other ways you can draw, but this is the easiest one I can find, and you can really read on the Canvas API to see things you can use in here. To make this a little more interesting, I am going to put in another set of commands here. We are going to draw another path. It is going to be filled with red. It really is the same thing. We are moving to the center and we are drawing another arc. The only difference is that this one has a smaller radius, and notice where it is starting from. It is starting from pi multiplied by 1.5, and it is going up to pi in the clockwise direction. Let's run this and see what we have. And we are going to have this thing here. And if you look at this, you see that it is really following our commands. It is starting at this location, which is pi multiplied by 1.5, and it is ending at pi in the clockwise direction. This is something simple that I thought would be interesting. I think this looks like a very good logo, and it is very easy to do using this API. But you can also do the same thing in the QPainter API that we saw in C++, but it is a matter of other factors that you can follow to choose whether you do this completely in QML or if you do it in C++. The purpose of this lecture is to make you aware of this capability. If you want to learn more about the Canvas API, the best place to go is the JavaScript documentation itself. We are actually going to go there right now, and here we are, and this is the documentation. You can look at it, see some examples, and play with these things. One thing you should know is that this is web-based, so you need to use some HTML to wrap around and put in a few JavaScript tags, but that is not very complicated. You should be able to play with us and know more about the Canvas API, and once you have this knowledge, it is going to be very easy to apply the same things in QML. Okay, this is all I had for this lecture. I hope it was informative to you. I'll see you in the next one. Congratulations on finishing this chapter. The bulk of the chapter was really on using the QPainter API to draw our stuff in the paint method of our class. And when we expose our class for using Qt Quick, we were able to see the shapes we have drawn in the paint method. The goal of this chapter was to make you aware of the possibilities. All we did was really scratch the surface on what you can do with QPainter. Later, if you happen to need more, you should check the documentation and unlock all the powers that you have with this API. We also saw how you can use list properties with visual types. This gave us a clean and readable API that our users could use in QML. And we closed the chapter making you aware that you can also do pretty complex stuff in QML alone using the Canvas API to draw all kinds of crazy shapes. In this lecture, we're going to give you a brief introduction to singletons if this concept is foreign to you. Singletons are really not complicated. They are just a way to allow you to have only one single instance of your class throughout the entire application. And sometimes there are good reasons you need to do this. When your class is used as a singleton, the constructor is only called once because you obviously only have one object that you are using all over again. This is a simple example of how you would implement a singleton in your C++ code. You see, this is a singleton class, and you create the instances of your class using the getInstance method here. And you see that it checks to see if there is an instance of that class. If there isn't, it's going to create a new one and return it. If there is already an instance, we're going to fall here and return the instance that is already available. So it's really simple. So why would you want to use singletons? Well, There are many reasons you might need to do that, and I have a few listed here to kind of give you a reference. For example, if you have an object whose job is to log in your application, you don't need to create this object really all over again. You're going to only create one instance of logger, and it's going to log wherever you need to log something to the console or wherever you want to put your output. You can also use singletons for caching, configuration settings, and all kinds of crazy things really. The facility is here for you, and if it makes sense to use a singleton, use a singleton. It's going to make things easier performance-wise. Okay, now you have an idea about singletons. In this section, we are specifically interested in how you can expose your C++ types to be used as singletons in QML. We're going to see how you can expose your C++ data wrapped in a QJS value object, and we're going to see how you can do the same using a Q object pointer, which is going to give you some benefits as we are about to see. In the next lecture, we're going to see how you can expose your C++ type and use it as a singleton in QML wrapped inside a QJS value. I'll see you in the next lecture. In this lecture, we're going to see how you can expose your C++ class as a singleton type to QML. We're going to be accessing the data from a QJS value object that we have on the C++ side. This technique is going to allow you to expose your data to QML as a singleton. Your data is going to be wrapped in the QJS value. If you don't know what this class is, let's go to Qt Creator and look at it. We can come in the help here and type in QJS value. And if you look at it, it is a class that acts as a container for Qt JavaScript data types. You basically use it to wrap around some static data that you have stored in this object, and you can access it from QML. So how do we do this? How do we expose our data? Well, you create a class in C++. The class has to do the usual stuff, inherit QObject, provide this macro here. It really is a regular C++ class. The only requirement is to provide a method that is going to return your QJS value. It's going to take two parameters that you can use if you wish so, a pointer to QML engine and a pointer to QJS engine. And it is in this method that you specify the data that you want to expose to QML. In this case, we have an integer value, which is 5. We are creating a new object here, storing it in the object of a QJS value, and we are putting some properties inside. You can put in as many as you want. You can also put in an array. You see that we create an array and we put some data in the array by setting some properties. And then we set that array as a property of the QJS value object that we have on top here. And we return the JS value containing the data we want from this function. And this data is going to be automatically available in QML. So how do you expose your data? Well, we have a way to do that here. You say QML register singleton type. You pass in the module name. In this case, it is com/blycon singleton data. And you specify the measure version, the minor version, the name of the API in QML, and last but not least, you specify the pointer to your singleton provider method. In this case, this method is defined in the singleton class, so we access it like this because it is a static method. This is not the only way. You can also do this using lambda function notation. You can register the type immediately like this and provide the pointer to the singleton provider as a lambda function. You see, this is a lambda function. This is the parameter list. You see that it is the same signature we had in the class, and it returns a QJS value. It really is the same thing. We are just doing things differently by using lambda functions. Inside, we also do the same thing. We create our objects, stuff that into a QJS value object, and then we return it after we are done with putting in the data. This is really all you have to do to expose your data. Again, we use QJS value here. There are other ways we're going to look at to work with singleton types, but right now we are using QJS value, and this method is good when you only have some static data that you don't expect to change and you want to expose that to QML. In this case, we don't expect this value here to change, and we don't expect this array here to change. This may come in handy if you have some settings or some data that doesn't really change that you want to expose to QML. We're going to go to Qt Creator right now and see this in action. Here we are in Qt Creator. We are going to create our project. It's going to be a Qt Quick application. We are going to call it Singleton QJS Value Demo. Choose our Qt version, choose the kit we want to use, and finish. We want to change the title here to say Singleton. We also want to create our Singleton class. Let's do that. It's going to inherit QObject. We want to include the two classes that we're going to need, QML engine and QJS engine. We also want to provide our Singleton provider. It is going to have this signature here. We just saw this in the slide. It's going to be a static method. It's going to return a QJS value, and it's going to take QML engine, a pointer to that, and a pointer to QJS engine. Let's implement this in the CPP file. Let's say we want to expose an integer value. Let's say m value. Let's say it is equal to 5. We want to create our QJS value object. Let's call it JS value. It is going to be equal to engine new object. You can check out these methods in the documentation. It basically creates a new object for you that you can stuff some data inside. So we can say JS value set property and say some property and pass in m value. We can also put in an array. It is easy to do. We can just say QJS value and we say engine new array. You can create an array like this and specify the number of items that you want in the array. We can loop over the array, setting each item in the array. I am just going to put in the loop. It really is very basic stuff. We just loop through the array, putting in the properties and multiply the index we are at in the loop by 5. We can also put our new array into this JS value. We can say JS value set property, let's say m array, and pass in m array like this. And then we can return this JS value. And it is automatically going to be available to QML when we expose this class as a singleton type. The remaining thing really is to go back to the main CPP file and expose this. Let's go there. We're going to include our singleton class. And we want to say QML register singleton type. We want to pass in the module name. It's going to be com. We want to pass in the major version, the minor version, and the name we want to use in QML. And last but not least, the pointer to the singleton provider method. We're going to say singleton class, singleton provider. It is a static method. We just want the name of it, just like this, and we are going to be fine. We can go to QML, import our module, we also want to import Qt Quick controls because we are going to need a button. We are going to create the button. ID is going to be m button. The text is going to be click me. You can put in whatever you want. What's really important here, we're going to click on it and access the properties that we have in the singleton. We can say console log my API, some property, which is the key we use to put the data in the JS value object here. The data is going to be automatically available on the type we registered the singleton as. So we are basically going to say my API dot and pass in the keys that we use to store the data. You're going to see this print the value we stored in the singleton provider here, and it's going to be a 5, which is what we are going to print here. Let's run the application and click on the button. Fingers crossed, you see we print a 5, which is the value we stored in here. We can also access the elements of this array that we stored in here. But before we do that, notice that we stored by saying marray set property, passing in the key as the index in the loop here, or the iteration, if you will. So we are going to use these indexes here to access the elements in the array. The first element is going to be a 1 because we are starting from 1. The second element is going to be at 2, and the third element is going to be at 3. At 1, we are going to have a 5. At 2, we are going to have a 10. At 3, we are going to have a 15. Let's go to main QML and print out these numbers. We're going to say console log my API. We're going to say marray. The third element should be a 15 if we are correct. The app is here, and you see we have a 15. Let's try and print out the first element. It should be a 5. And we have a 5 here. Let's do 0 to show you that if you try to access 0 here, you're going to get something unexpected because there's nothing in there. We didn't send the value to be there, and it says undefined. We can also go back to QML and print out every element in the array that we exposed. The way you do that, you can say my API array and do a for each loop on that, and inside we are going to print the element we are at. We're going to say console log element. I think this will do. Let's run. Click this, you see 5, 10, 15. We are printing the elements that we put in this array here. Okay, this is one way to expose your data as a QJS value object by providing a pointer to the singleton provider method. But you can also use Lambda functions here and provide your singleton provider method immediately when you register your type. The way this works, you basically have the same thing. And let's put this here, delete the singleton provider here, and put in a Lambda function that takes the 2 parameters we took here. It basically is the same thing. We are just changing the syntax we are using to do these things. We want to return a QJS value, and we want to put in our body in which we are going to do all the things we want to do. It is nothing new really. We just want to copy everything we have in here and move it over in our Lambda function. And it is going to work hopefully. Control A, Control I to align, to have things aligned up nicely. All you have to know is that this is a Lambda function that is replacing the pointer to the singleton provider that we did in the first syntax here. And if we run, you're going to see that everything is still working the same way it did before. Click, and you have your data here. You notice that we have a warning here saying that we have an unused parameter, which is script engine. If you don't want this error, you can say QUnused and pass in the parameter that is not used, and it happens to be script engine here. If you run again, this warning should disappear, and it does. Okay, this is all I had for this lecture. In the next lecture, we're going to see how to do the same thing, but use Q objects instead of QJS values. We saw that QJS values are for static data that you don't expect to change. Q objects allow you to store the data that you expect to change in some way. I'll see you in the next lecture. In this lecture, we're going to see how you can expose your Q objects as singletons to be used in QML. You already know what a singleton is. It is a class for which you only want one instance object throughout the entire application. You want to expose it to QML, and you're going to wrap your data in a Q object class. It is recommended to use this technique when your data is changing on the C++ side, and you want to be notified of the changes on the Qt-Quick side. We're going to see how this works. You create your singleton class, and it has to do the usual stuff. Inherit Q object, provide the macro. You want to put in the property you want to expose here in this Q property macro. And you see we have the usual setters, the getters, and the signal down here. The interesting thing is that you have to also provide a singleton provider. You see that it looks like the one we saw before, but this one is returning a Q object pointer. If you go down, you see that it is creating an instance of the singleton class here and returning it. And this way, the class is going to be available to QML, ready for you to manipulate. And this property is going to be changing over time. That's why we have a timer here. And we are going to be notified of the changes in Qt-Quick. You expose the class in this way. You say that you are exposing singleton class. You put in the module name. We are changing it a little bit to make it different from what we did in the last lecture. It is available as my API, and you put in a pointer to the singleton provider as we did before. You can also use lambda function notation. We just saw this, and it works exactly the same way we did in the last lecture. We are providing the capture list, the parameter list, the return value, which is a Q object pointer, and inside we do our usual thing, creating an instance of singleton class and returning it. We are going to go to Qt Creator and play with this. Here we are in Qt Creator. We are going to create our project. It's a Qt Quick application. We are calling it singleton Q object demo. Save it in the usual location. Hit next. Choose the Qt version you want. Choose the kit you want to use for this project and finish. We want to change the title here, and we want to create our singleton class. It's going to inherit Q object. We want to go to the header. We are going to include the classes we're going to need: QML engine, QJS engine, and QTimer. We need to provide the property we want to expose to QML. Let's close this pane here so that you see the entire thing. It basically is an integer, some property. We have a getter, a setter, and the notify signal for when something changes about this property here. We want to generate the methods, but before we do that, let's put a private section so that our fields are automatically put there. And here we are, we have a field here. Let's move these methods, the implementations of them, to the CPP file. Let's find the other one, set some property, move to CPP, go to the header again, and do some cleanup as we usually do. Move the method to the public section of the class, Control A, Control I to align, and things look better now. We want to put in our singleton provider. This is the meat of this demo here. We want to implement it. And these two things are not going to be used, so we should say Q unused on them. Pass in engine and say Q unused for script engine. Down here, we want to say singleton class pointer example equals new singleton class and return example. We forgot our semicolon here. Control A, Control I to align, to have things aligned nicely. And this is really all we need to expose the class here. but we didn't provide the mechanism for us changing the property that we have in here. We're going to create a timer instance, QTimer, pointer mTimer. We go in the CPP file and initialize a few things. Our property is going to be initialized to 0. And the timer, you know what we're going to do. New QTimer. And give it a parent like this. We actually want to put in some debug statements, so we should include qdebug and say that we are creating an instance of the singleton. We are going to connect to the timeout signal of the timer, so we're going to say mTimer # timer timeout. We are going to use a lambda function, and we put in our parameter list and our body, and we want to change our property. We're going to say set some property. Let's capture the current value and add 3 to that. We're just trying to change it to show you that the changes are propagated to QML. We're going to start the timer and let it time out every 2 seconds. For example, we're going to say mTimer start 2000 for 2 seconds. The units here are in milliseconds. And I want you to see that when we change some property, we emit the signal to say that the property has changed. Now we can go to our main CPP file and expose our class, include singleton class. We are going to register it as a singleton type. I am going to put in the code to save on some typing. It basically is this syntax here. It is going to be available in this module, measure, minor version, the name you're going to use in QML, and the pointer to the singleton provider, which is defined in our class here. This is exactly what we have. Now we can go to QML and import our stuff. We're going to say import QMLAdvance singleton data 1, and it's going to be available in version 1.0. Let's double check this. I am going to copy this, come back to QML and put it in here. That way I'm going to be sure. I am going to put in a rectangle. It's nothing fancy really. It's just a rectangle with a bunch of properties: width, height, radius, the color. Inside we have a text component that is accessing the some property that we exposed in here. The color is going to be white for the text, and we have it centered. The font is going to be this big. We can run the application and see what we get, and we expect to get a rectangle with some data that is changing every 2 seconds. Let's see what we get. We have 0, it's going to be a 6, a 9, a 12, because we are adding 3 to our data every 2 seconds. This is working the way we want, and you see that they say that singleton instance created. I don't think I showed you that we only have one instance of this class throughout the entire application. To show that off, I am going to close this and add another rectangle and also set it to some property here. Let's go down below this rectangle and put in another one, Control A, Control I to align. It is just set to be to the right of the first rectangle. The rest is really the same, and we changed its color to blue instead of red for the first one. We are accessing this property 2 times. So one might think that we are going to create 2 instances of the class, but we are only going to have 1 instance. And the proof is going to be that we are going to have 1 call to the constructor of the object, as you see here. The application is going to be here, and the data is going to be changing simultaneously because we are using 1 object. I hope this makes sense. Now we can expose some singleton data wrapped in a QObject class. The next thing I want to do is to show you that you can also expose this using the lambda function notation. It is really easy to do. I am going to comment this out and put my comment in here, and I am going to copy this and change it a little bit. I am going to remove this singleton provider and put in my capture list the parameter list. I am going to steal this from my CPP class. I think I have it here. Let's copy this, come back to main, put this in here. I am going to provide my return value, which is going to be a QObject pointer. And I need to provide my body, just like this. Inside, I am going to do exactly what I do in my singleton provider, which is part of this class. I am going to come back to main CPP and put that in here. If I run the application, I should see the exact same thing as we did before. And it really is a matter of preference which one you like. They all work the same. This is all for this lecture. I hope you know how you can expose your data as a singleton type, and the data that you want to expose is wrapped in the QObject class. In the next lecture, we're going to continue on singletons and show you how you can expose some data completely from QML. I'll see you in the next lecture. In this lecture, we're going to see how you can expose singleton data completely from QML. This is going to be really easy. The only thing you have to do is to create a QML file and start it with pragma singleton like this. You're going to import whatever modules you need for your functionalities to work, and you're going to put in your properties like this. In this case, we are exposing an integer. It is called testprop1, and its value is going to be 125. How do we expose this to be available as a singleton type in QML again? We do that like this. We say QML register singleton type. We pass in the URL, and the URL contains the location of the file. In this case, it is in our resource file, which is where you should really put all your files that you want to be available to your application. We put in the module name, which is QMLAdvance QML singleton, and we put in the measure and minor version, and we specified the name we are going to use to access that in QML. Let's go to Qt Creator and see this in action. Here we are in Qt Creator. We are going to create our project. It's a Qt Quick application as usual. We're going to call it QML Singleton Demo. Save it in the usual location. Choose the Qt version we have installed. Choose our kit and finish. Our singleton data is going to come from a QML file, so we should add a new one like this. Select QML QRC here and say add new. Go to Qt and choose QML file, Qt Quick 2. Let's call this QML singleton. Hit next and finish, and you have the file here. The first thing you need to do in this file is say pragma singleton, and inside the item element here, you can put in your properties. You can say property int. Let's call this test property and give it a value, let's say 5678. And this is really all we need. You can put in whatever property you want, strings, bools, whatever. Now we want to come back to the main CPP file and expose this to QML again. The data is coming from QML, and we want to expose it to QML again as a singleton from the C++ side of Qt. All we have to do is say QML register singleton type. The first parameter is going to be a QURL, and it is going to be the location of your singleton file in the resource file. The easiest way to get that is to right-click on the file and copy URL, the one that starts with QRC. You can click on this to copy it, and then we're going to paste it in here. The next thing is going to be your module name. In this case, it's going to be QMLAdvance QML singleton, the measure version, the minor version, and it's going to be available as QML singleton. This should be all we need. we can head to our main QML file and import our module here. So we're going to copy it, go to main QML and import that. Say import 1.0, our versions. And we're going to make this very easy. We're going to put in component on completed. When this is completed, we're going to say console log QML singleton test property. Let's see what we called it. It is called test property. Let's copy this, come back to main QML and put that here. And we should see that when this application runs. Let's change the title here to let it reflect what we are doing here. Let's run the application and we should see our number here printed to the console. 5, 6, 7, 8, and we have it here. And this proves that we can read the data that we stored in our QML file and use it as a singleton type in QML again. This is really all there is to this. In the next lecture, we're going to review different ways we saw to register singleton types in C++. I'll see you in the next lecture. Congratulations on making it to the end of the first chapter of the course. And I hope you now know more about ways you can expose your C++ data to be used as singletons in QML. We have seen that when you expose your singleton wrapped inside the QJS value, this can come in handy when you have some static data that you want to expose to QML. For example, if you have settings that don't really change throughout the lifetime of your application, it is a good idea to expose your data using QJS values. If your data happens to change that often and you want to expose it as a singleton, it is a good idea to wrap that in a Q object as we saw in the chapter. And finally, if you really don't want to mess with C++ that much, there is a way you can completely expose your data from QML and expose that as a singleton in C++. In this lecture, we're going to see how we can dig through the QML tree structure from our C++ code. But before we do anything in this chapter, I'd like to warn you about something. What we are about to see in this chapter is really not how you should be integrating your QML code with your C++ code base. Your C++ should know as little as possible about how your QML tree is structured, because if the working of your application depends on the structure of the elements in your QML, your code base is really not going to be that maintainable. I have pasted in a piece from the Qt documentation itself. You can read it loud and clear and really keep that in your mind. We are going to do what we are about to do in this chapter just to make you aware of the possibilities, and because we live in a crazy world, crazy stuff does happen, and sometimes you may have a valid reason to do this. So I'm going to show you how to do that. Along the course, we're going to see how you can parse your QML based on the QML engine class. We're going to show you how you can read your data from a C++ custom type that you are using in QML. We're going to show you how to load visible items using QQuickView. We're going to show you how you can invoke QML methods that are not at the root level of your QML tree. And we are going to use QQML application engine to really do the same thing. And QQML application is really a convenience class that is going to allow us to do what we've been doing all along in this chapter. We're going to wrap up the chapter by showing you how you can respond to a QML signal in C++. In the next lecture, we're going to start doing all this. I'll see you there. In this lecture, we're going to see how we can use QQML engine to load QML objects in C++. I want to talk a little more about the goal that we have here. Our goal is to take a QML file, that is this one you see here. We have an item, inside we have a bunch of other items, and child items have children of their own. We really have a tree structure. Sometimes we want to be able to parse this tree and get items and be able to manipulate them from C++. And this is really the goal of this chapter here. So to read this, the first thing you really need to do is to get the root item. And the root item is really a C++ object that represents the entire item that you have here. The outer item here that we call the root item. Once you have the root item, you can call a bunch of methods on it to get child objects inside the QML tree. And for that to work, you're going to need to define something in your QML that we haven't really touched on so far. and that is the property called object name. This is different from the ID that we have been using in QML. It is specifically used when you are parsing objects. Okay, so you see here the root item has an object name called my root item. And if you go down, you're going to see that all the items also have object names. And we are going to be using these object names to get the particular item that we might be interested in the QML object tree here. So how do you get the children? There are two sets of methods that you can really call. If you need to get one child, you can call find child on the root object. If you need to get multiple children, you can call find children. And you can see that you need to specify the class that you want to parse that as, and you specify the object name. You see here we are trying to get child1, and which is this one. Here we are specifying child2, which is a bunch of other children that we have in here. You're going to see. When you are finding children, there are two ways we can do the search. We can do the search recursively, running deep down in the tree, trying to find out the item that we are interested in, or we can find children only and only search at the root level if we are calling from the root level here. I hope you get the idea. Okay, so far we know about the root object. We know that we can call find child or find children and passing in the object names to get the particular object that we are interested in. And we are going to have that as a Q object pointer here, or a list of Q object pointers. Once we have the object, we can do some operations on it. We can write its properties or we can read its properties. There are two ways to write properties. You can use QML property write. You pass in the object that you got with find child or find children. You specify the property that you want to write in the second parameter here, and then you pass in the value. Or you can call the set property method on the object and specify the property as the key and the value as the value. Reading properties, we also have two syntaxes. We can use QML property. We read the property and we turn that into a string, because when you read it like this, it's going to come out as a Q variant. And we do the same by calling property and passing in the key for that property and then turning that into a string. When setting properties, these two syntaxes are a little bit different. I am going to elaborate more on the differences in a few upcoming lectures, but for now, know that you can write to the properties or read from them. Now that you have an idea about this, we're going to go to Qt Creator and play with this a little more. Here we are in Qt Creator. We're going to create a new project. It's going to be a Qt Quick application. We really want to do a console application, but we are going to start here so that we have the boilerplate code for us from Qt Creator. We're going to call it loading QML files console CPP demo. We're going to store it in the usual location. Hit next. Choose the Qt version that you want to use. You choose the kit. And in this case, we use desktop MinGW 32-bit. And we're finished. Now I want to do my changes. If you go in the main CPP file, you're going to see that we are using QGUI application here. We want to make this a console application. So I want to change this to QCore application and change this to be QCore application. And we really not are going to need this line. The other thing we need to do is to go to the project file. The project file, if you don't know it, and you should really know it by now, it is this PRO file. Double click on it. We are doing a console application. We are not going to need this QQuick module. We are going to need core, GUI, and QML. These are the modules that we are going to need. So put them in here. Once you have your modules set up right, I want to come back to main, and we are not going to use this piece of code here, because we want to use QML engine, a really low-level option to QML application engine. I just want you to be aware of it and how you use it, so that when you see it out there, you know what is happening. For this to work, we need to include it. We're going to say QML engine. We also want to include QML component. It is this one. And what we want to do, we want to say QML engine let's say engine. After this, we want to create a QML component. We want to pass in the parent, which is going to be the engine we have here. And we want to pass in the file, the QML file that we want to load. It is going to be exactly the same as the QML application engine. So we are going to copy it and put it in here. This is going to be fine. And we should be able now to create our root object. We're going to say QObject, pointer root object, and it's going to be equal to component create. This is going to return it. We don't need to pass in any parameter. This is going to give us the object that wraps around the QML file that we have in here. But to make sure that something is running, we want to include QDebug. Let's say include QDebug and come down here and say running QML application so that we see something on the console. QDebug running QML app. This is going to work. We need to do one more thing. We want to come to the QML file that was generated for us. You see that we are trying to load some visual components. The window here is a visual component, but we are doing a console application. So this is going to burst on us. What we want to do is remove this and change this to item. Let's take out all this here and say object name equals my root object. We want to print out the object name of this. Let's say QDebug object name is, we want to capture root object and say object name. Done. This is what we need to do. Let's run the application and see what we get. You see that the application is running right now, and we are seeing our output here, but we're not seeing anything visual because this is a console application. Okay, we are moving forward. Let's close the application and modify the QML file here to be a little bit bigger. I am going to put in another QML file that I had prepared, the same file we saw in the slides reading, and we're going to try and parse it. Let's close this, delete everything we have in here, and you see that our file here is just a tree of items inside the item here, which is at the root level. It has an object name, and inside we have a bunch of objects. We're going to go to QML and try to parse this. First, let's get rid of this. We don't need it anymore. We also don't need this anymore. Let's clear that. Let's first try to print out the number of children in the QML file. The way you do that, you say QDebug. We can say root object children count. This is going to give us the number of children inside the QML file. Let's go there and try to see what we can expect. We have one child here, 2, 3, 4, 5, and 6. We have 6 children in this item here, which is the root object. So we should see a 6 as the number of children when we run this application. And we see 6, you see that we are correct. Now we want to read some children from this QML file. For example, what if we want to find this item here? Its object name is child1, and it has a bunch of properties, and we want to capture these properties and read them in C++. How do we do that? We can say read child. We are going to say QObject pointer child1 equals root object find child. It is going to be a QObject pointer, and the object name is going to be child1. We can copy this and put it in here, and we have to check if what we searched for has been found. So we should say if child1. We fall in here if this call was successful. If it wasn't successful, we are going to get a null pointer, and we are going to fall out of here. So inside, what do? We can read the age of the child. We're going to say age is And remember, we have two syntaxes to read properties from objects we get from QML, and any Q object really. The way we do that, we say QML property. That's what we want to use for now. And notice that we didn't include that, so we should include QML property, not properties, property. And if we do this again, QML property, we're going to read the property. We need to pass in the object we want to read from. It is child1 in this case here. We're going to say child1. The property we want to read is age. Let's go back to QML and make sure it is age here. We want to turn this into an integer because that's what we should read it as. Let's try and run. We should see age is 13 if we are working as we should, and age is 13 here. We are able to read that property. I want to show you another syntax you can use to read this. It really is very easy. You just have to call a property on the object. We're going to say child1 property, and you have to pass in the key for the property. And you have to turn this to int as well to be able to see it. And if you run this, we are going to see age is 13 two times. Let's run. Age is 13 two times. This is working. The other property that we have in here is names. We can also read that. We are going to use one of the syntaxes. We're going to say qdebug names and say child1 property names, and we turned it into a string because that's what it is. Let's run the application, and we should see Steve Barker as names. This is what we have here. I hope this makes it very clear that it is very easy to read things from the objects that you get from QML. You really need to know the property that you have in QML, and you pass in as a key when you are reading with these two syntaxes. Either of these two is going to work fine. To practice safe programming, you should come in here really and say that you couldn't get this object because this call failed here. If we don't fall here, we should fall here. We should say qdebug could not get object with child name, the child name that we specified in here. And this is going to be more descriptive if we don't get anything here. This is going to help out if something goes wrong later. Let's go back to QML and see what we can cook up. We also have a rectangle object. We can read all these properties and even modify them from C++. Let's go back to main CPP and cook that app. We are going to find the object the same way really, and its object name, it's child rect, you see here. Down below, we want to say f child rect. We are going to do a bunch of things. We can print out the properties of the rectangle. We capture its width, its color, and its height. Let's try and run this and see what we get. Width is 200, height is 300. Let's verify that. And this is what we have here. We also have a color, which is green. And if you go down here, this is a green in X format. We can also modify the properties of this rectangle. Let's say that we are about to do that. Because we are going to play with the color, we are going to use the QColor class. Let's include it, QColor. And go down here. We want to prepare a color that we want to use. Let's do QColor, color, make it a red. And we want to set the properties of this rectangle. You already know how to do this really. We're going to say child rect and call set property. The property we want to set is the width. So we're going to say width, and we want to make this 600, for example. You can also set the height. To show you the other syntax, we are going to use it. We're going to say QML property and say right. We are going to pass in the key as the height, and we pass in the value. We say Q variant from value and say 600. We want it to be the same as the width, and we should really say the same here. So let's do that. Copy and replace that with this here and put in our closing semicolon here. And here when you use write, remember, we should pass in the object that we are trying to write to. So we should say child rect here. And you see the line here is going to go away. We should also set the color. We're going to say child rect. I really like this syntax. It is more natural for me. We're going to say set property. We're going to say color. And we should pass in the color that we have on the top here. And I am going to put it in right away. Now that I have this set, I should try and output it again so that you see that the properties have changed. I am going to say qdebug, printing out new rect properties. And I am going to just copy this and print them out again. This is going to save us some typing. Let's run. We should see the original properties and see the new properties for the rectangle. And you see that we had 200 and 300, and now we have 600 and 600. And the color have changed from the green that we had before to a red. You see, this is the hex value for the red color. We are able to read properties and change properties. This is fun, isn't it? We have played with find child. Now I want you to have a chance to also play with find children. We are going to do that. We are going to say QList because we are going to capture that as a list of object pointers. We are going to say children root object find children, and they are going to be Q objects pointer. And we want to find children who have the object name of child2. Let's expand this and show you a few things in here. This is child2. We also have another child2 somewhere. So let's find this. And you see this is child2 here, and this is child2. They have a property of car, and we have a car brand in here. So we are going to find these two children, and we are going to print out the brands of the cars. Let's go back to CPP and do that. So the object name here is going to be child2, which is what we had in the QML file. We want to say if children count is greater than 0. We want to print out the children that we have in here. We want to say that we got some children and that we are about to print the car brands. Right now, we can qdebug the car brand is and say object property and say the brand. Let's go back and see what we have. It is called car. So we should say car here and turn this into a string so that we can see it when we output it. And this should really be all we need to do to read these properties. Let's run. Object was not declared in this. We have Q object here. Sorry. Let's run again. We see the car brand is Peugeot and the car brand is Ford, which is what we have exactly in our QML. We are able to target these children by their object names here. The next thing I want you to see is how to do a recursive search and do a search that only finds direct children. If you go down here, you see we have deep child, which is a direct child. And inside we have another deep child with a string property level with the value of level 2. And inside we have another deep child. So if we search recursively, we are going to get all these children. If we search to find direct children of the root object here, we are only going to get level 1. Let's go to main CPP and see how we can cook this up. We want to find a list of objects. We want to really do the same thing, root object, find children, and we are going to specify the object name that we are looking for. This time it is deep child. Let's go to QML and specify the same thing here. I am really worried about getting typos. And by default, it is going to find recursively. Okay, so let's flag that here. Default recursive. We can look through the items that we get in this list, deep children. Just to make sure that we get what we expect, I am going to put in a piece of code that I have prepared. It really is nothing new you haven't seen. We are just checking to see that the list is not empty, and we are saying that we got a number of items, and we are looping through the list, printing the child level that we got. Now the search is recursive. We expect to get all the 3 children that we have in here, which is deep child here, level 1, deep child at level 2, and deep child at level 3. And I actually had forgotten that we have another one here. We are going to get 4 children, as you see here. A better way to show things you are searching for is to select the string here and say Control F to find, and it's going to show you your strings highlighted like this. So we expect to see 4 items. Let's run. We see level 1, level 2, level 3, and level 1 clone, and we have 4 children, and this search is recursive. And because the default is to find recursively, if we specify to find recursively like this, we are going to get the same result as before. Let's run. Okay, we have the same thing here, but we can specify to find direct children only. And what we are going to get are direct children of the root object here. And we are going to get only level 1 here, which is a direct child of the root object. And we are going to get level 1 clone here. We are going to get 2 items. Let's run. And 2 items, level 1 and level 1 clone. I really hope this shows you different ways you can loop through the items that you have in your QML tree and capture the properties and even change them as you see fit. This is really all I had to say in this lecture. The main point was to show you that you can load your QML file using QML engine, just like this, and you can get the root object, and then you can parse the root object using the find child and find children methods that we have used. And you need to know the object name of the item that you are looking for in the QML tree. And last but not least, you can search recursively or find direct children of the object that you are interested in. In the next lecture, we're going to see how you can parse your own C++ type that you are defining in QML and read the data back from C++. I'll see you in the next lecture. In this lecture, I want to lay the foundation to what we are about to do in the next one. We're going to look at the football team class that we're going to parse. It is a class that we have built before, and the API is usable in QML like this. It is a football team. You can specify a bunch of properties. We have the title, the coach, and you have object properties inside, and we have list properties down here. Let's go to Qt Creator and see how this is put together, because we're going to need to import these classes to be able to parse them in the next lecture. Okay, here we are in Qt Creator. This is the project, and you're going to have to download the source code on this lecture and use this in the next lecture. When I open a previous project in the next lecture, you're going to open this one, and it is going to be attached to this lecture here. We have a football team here. It really is simple if you have basic knowledge about how you interface C++ to Qt Quick. We are using the QProperty mechanism to expose our properties. We expose our list property here, and we have our methods to kind of support the features that we are trying to expose here. If you go to main, we are exposing our types for using QML, and in QML, we are importing our module and using it like this. This is really all there is to it. If you are confused about how this is put together, I recommend to learn some basics about interfacing C++ to Qt Quick, or even watch one of the previous courses that I have on the subject. We cover these things in detail. Okay, now you have this, you know where to get the code when we need that in the next lecture. We're going to stop here, and in the next lecture, show you how you can parse this class from C++. I'll see you there. In this lecture, you're going to be able to parse your own C++ type back from QML. What do I mean when I say back from QML? Well, for example, here you see we have a football team type. I say back because it is a type that you expose to QML. Your users are going to be able to define objects in QML like this, and you want to have the ability to parse this type and read it as a football team object in C++. I hope this makes sense. If it's not clear yet, bear with me. We're going to go to Qt Creator and do this step by step. Here we are in Qt Creator. Before we create our project, I want to open a previous project we are going to copy the football team and player classes from. So I am going to open File or Project, and I am going to open the object list and properties demo project. So you can go back in the course and find the source code for this and download it and open it, because we are going to copy some things inside. I am going to open it, and I have it here. It is called 4.5. I am going to create my new project. It's going to be a console application this time. I just want to show you different ways to do the same thing. We're going to call it parsing custom CPP types demo. This is going to be enough for us. We're going to choose the kit we want to use, and we're going to finish. If you look here, it is a QCore application we are using. And if we go back to the project file, we need to import the modules that we want to use. This is not going to be enough for what we want to do. We should go back to the previous projects that we did and copy these things from there. Let's close everything for now so that it doesn't confuse us. Come back to our project and put in the module, and this is going to work fine. I want to go to the project that we just opened. I want to go where it is saved, find the location of main CPP by opening Show in Explorer. I am going to copy football team and a player here because that's what I need. I am going to copy those, close this, come back to where my project here is stored. I am sorry if this is convoluted, but this is what you need to do to get these things working. I am going to go to the location where the main CPP of my project is stored, and I am going to put in my files here. Close this. I want to come back to my project here and add existing files, and I am going to add football team and player here. And they are going to be available as header and source files here. You see, I have a headers folder and I have a sources folder which contains my main CPP, player, and football team. I actually need to add my own QML file. So I should add a new resource file. I am going to come to Qt here, Qt resource file. I am going to call this QML. All this was done for us by the project template that we wrote it before, but now I want to show you how you can do this yourself if you happen to need that. It is going to give us a resource file. We need to add a prefix. We are going to delete all this here, hit enter. To add our QML file, you can come to the QRC file here and add new and say Qt. It's going to be a QML file that you want here. And you're going to call it main and hit next, and you are going to have a QML file in this folder here, and this is what we're going to have. I am going to put in the QML file that we are trying to parse. It's really nothing complicated. It is just a football team inside, and inside the football team we have a bunch of properties. Our goal in this lecture is to be able to parse this from C++. You notice that these things here are not recognized. So we should go to main CPP and modify it a little bit to use our thing. The main CPP is going to include a bunch of things. We are going to put them here in a batch: QQML engine, QQML component, property, debug, player, and football team, the classes that we define in here. We are going to register the types, Control-A, Control-I to align for use in QML. You already know how to do this. We are going to create our QML engine and the component, and we want to create a football team object from this file here because we know that it only contains a football team here. So the way we do that, we say we want a football team pointer object. We want to do QObjectCast. We want to cast to football team pointer, so we're going to do that. And what we cast is component create. If you remember, this is going to return a QObject pointer. We want to cast it to a football team. And right now, we should have a football team that we can work with as we normally do in C++. If you look in the football team class, we have a bunch of methods that we can use. We can add players, we can get the number of players, we can get a player at a given index, and things like that. We're going to play with this in a minute. Let's go back to main CPP and check that this actually worked. We're going to say if team and team captain. If we have a team and a captain for the team, if you go back in QML, you see that we have a captain property and we have a bunch of players inside. We are going to read these players. Let's go back in main CPP and QDebug the name of the team. And we are going to say team title and say the captain, team, captain, and say names. And just like this, we can read the name of the captain. Let's try and run the application and see that it is working so far. Let's run QMake to reload the objects and run the application to see what we get. We don't have football team here. What is wrong? Let's go back and see what we have as the class. The class is not called football with the lowercase b, it is a capital B. So we're going to go back to main and do this. This should work fine by now. Let's run QMake again, just to make sure things are loaded properly. Rebuild. And here we have another typo. I really am sorry for these typos and errors. Let's build again. Looks like we have a clean build. We should run, fingers crossed. And you see that we are having a window here. If you wonder why we got a window in this lecture and we didn't get a window in the last lecture, let's look at the PRO file. We are configuring this as a console application. That's why we are seeing the window. And if you go in the previous project, we didn't do that. So Qt Creator was handling our own output, but when we say console here, we are saying that it should display its own window. I hope this makes sense. We can run it and see what we have inside. This is the QML engine adding player objects to our C++ type. And the output we really are interested in this lecture is this one, Team Rayon Sport. The captain is Moti Johnson. And if you go in our QML file, you are going to see the same things. The title of the team is this one, and the captain is Moti Johnson. What I want to do really is to read all these players here. This is more fun. Let's go back to main CPP and expand this a little bit and say QDebug the players are and do a for loop. We are going to say for int ix equals 1, ix less than the team player count custom. This is going to give us the number of players in the team, and we are going to increment ix. Inside, we are going to print the player at a given index in the list of players that we have inside. This is really nothing complicated. We are going to say QDebug, put in a few spaces to separate things a little bit, and we are going to say team player custom, and notice that we need to pass in the index, and this is going to be ix for now. And if we run the application, we should see our players. And right now we are just trying to print the player objects. We really should get their names, so I am going to say name. Let's run, and we should have the names of the players listed here. Player 1, player 11, 12, and 13. And this is exactly what we have in here. We are able to parse a custom C++ type whose data was defined in QML. This was the goal we had in this lecture. In the next lecture, we're going to try and display a visual type using QQuick View. I'll see you there. In this lecture, we're going to load some visual stuff. If you look at the QML file that we have in here, we have an item that is wrapping around a rectangle object. And what we really want is to show this rectangle using the QQuickView class. This is the way we are going to do it. We are going to create a QQuickView. The source is going to be set to the QML file that we are going to have in our resources, and we are going to show the view. More importantly, we are going to keep a root object pointer that is wrapping around everything we have in the QML file, and we are going to be able to manipulate things in the QML file from C++. We're going to go to Qt Creator and do this. Okay, here we are in Qt Creator. We're going to create our new project. It's going to be a Qt Quick application this time because it makes the job easier. We're going to call it QQuickView Load QML Demo because that's what we are really doing. Next, choose the Qt version you want to use. You choose the desktop kit. That's what we want to use here, and finish. What I want to do is come to the main CPP file and modify a few things. You see that we are using QML application engine. This is not what we want to use. I want to modify it to use the QQuickView, and these are the classes that we are going to use. You should include them right now and take out everything you have below the QGUI application definition here and replace it with a QGUI version of our things here. Control A, Control I to align. It really is nothing complicated. This is going to load the QML file that you have in here and show it. But before we give control to our application, we want to grab a pointer to the root object that is wrapping around the QML file that we have in here. The way we do that, we're going to say QObjectPointer root object because that's what it is. And it's going to be view root object. This is how you get it. And if you want to know more about the QQuickView class and things you can do with it, you can visit it in the documentation. It really is straightforward. It is a class that allows you to show QML content, visual QML content. Before we try and run the application, I want to go to the PRO file and make sure that we have everything we need in there. For now, we are also going to need the QML module. So we're going to add it right here. Come back to main CPP. This is what we need. We go to QML and put in the QML file that we want to display. The QML file we just saw in the slides. The file is really nothing fancy. It is just an item that is wrapping around a rectangle, and we also have an object name on the item here. Let's change this import of Qt Quick to 2.11, the latest version as of now. And right now we should be able to get the object name of this root item here. Let's print it out just to make sure that we are loading our things. Let's say qdebug root object name and say root object name. This is going to do fine for us. Let's build the application and run it. It should show a window with our things here, and this is the window we defined. The width and height is what we defined in here, 200 to 300. If you doubt that this is the window we defined, you see that the color is what we defined, but we can also change the height to 200. Run again. And you see that we have the window that we want here. This is the width, this is the height. And you see that we say that object name is root. Now we want to be able to manipulate this object in C++ before we give control to the application. And it is going to modify it and make it show differently from what we see here now that we haven't done any modification. Let's go to the CPP file and try to change a few things. The first thing we want to do is to find the rectangle item inside our root item, this thing here, and we find it like this. You know how to do this already. We're going to check if we got a valid object. In here, we are going to cast it to a QQuick item, just like this, and we can modify its properties. Let's prepare a color, QColor, color. Let's make this a blue, and we can say item, set property, color, and pass in the color that we have in here. We can say item set property, say width. Let's make this 600. Let's say Q variant from value. Let's pass 600 in here. We're going to do the same to the height. Let's copy this because I don't want to type this again. Put it here, change this to height. And if we run the application, we should see a version that is different from what we had before. It should be blue rather than yellow-green, and it should be bigger than what we had here because it is now 600 in width and 600 in height. Let's run the application and see what we get. And if you expand this, you see that it is bigger than what we had before, and the color is not yellow-green as it used to be in QML before we do any changes from the C++ side right here. And ladies and gentlemen, this is really what I wanted to show you, how to load a QML file using QQuickView, and that you can hijack the object that you have loaded and modify it from C++ as you see fit here. In the next lecture, we're going to see how you can use QQML application engine to do all the things we've done so far and even more. I'll see you in the next lecture. In this lecture, we're going to use QQML application engine to do all the things we've been doing all along. If you noticed, we have been using QQML application engine all along in the course to load QML files to be shown in our application window. The only thing that is important to us right now is how to get the pointer to the root object and have the capability to modify anything in the QML file as we see fit. And as you see here, this is how you get the root object. And once you have it, you can do all the cool things we have been doing all along and manipulate any QML element that you have in your QML file, as long as you have access to its object name. We're going to go to Qt Creator and see how we can use this. Okay, here we are in Qt Creator. We are going to create a new project. It's going to be a Qt Quick application as usual. We're going to call it QQML application engine demo. It's going to be in the usual location. We choose the Qt version we want to use, and we choose the kit we want to use, and we finish. And as you see here, we have a normal project, and this side we are loading everything using the QQML application engine class. We can run this to see that it works, and it's going to work. Okay, this is the window we have here. If you go to the documentation for this class, it is going to tell you that it provides a convenient way to load an application from a single QML file. And this is what we are exactly doing here, loading this file here, which contains an application window. Okay, now we want to capture the root object. We're going to say Q object pointer, root object, and it's going to say engine, root objects, and capture the first one. You can either say 0 like this, and it's going to work, or you can just say first, which is what I like here because it is more intuitive, and you have a pointer to the root object. We can go to QML and change it to contain the QML file that we want to work with in this course. We can run it and see how it looks, and it's going to be a bunch of rectangles and some text here. If you go down here, you can see all these rectangles that we see. We're going to have the first one here. The second one is going to be at the bottom of the first one, and it's going to be blue. We're going to have a text area that is going to be at the right of the first rectangle. Rectangle 3 and rectangle 4 are going to be below the text item that we have here. Another thing you should see is that the width of rectangle 3 depends on the width of rectangle 4. And when you click on the mouse area here, you're going to change the width of this rectangle. And because of the binding that we have here, rectangle 3 is also going to change the width. We can bring the application up and verify that. We are going to change the width of rectangle 4 by clicking here in this mouse area. And as we increase the width of 4, 3 also follows in changing because of this binding. This is what we have, and we are going to try and manipulate this from C++. Let's go there. And the first thing we want to do is to print out the number of items that we have in the QML tree. We are also going to show the object name of the root object, which is going to be this thing here. We can run the application, and it says item count is 6, object name is root window. We can also do some other things. We can find the rectangles in the QML file, and we do it like this. You already know how to do this. We need to include QQuickItem for this to work. QQuickItem. We want to check and see what we get. I'm going to say flist, and inside we are going to loop through the items that we got from this thing here. We are going to check that the list is not empty. We are going to say if list count is greater than 0. We are going to say for each QQuickItem pointer, let's call this item, and we are going to work on the container of this list here. Inside, we are going to access the properties of the item. We can say Control-A, Control-I, item, saying that we got the item, and we're going to print its color. But before we loop through the things, I think it is a good idea to show the number of items that we found. So we're going to say QDebug, item count, let's say rectangle count. It's going to be list count like this. Let's run this and see what we get. And you can see it is saying could not. Here we messed up. We shouldn't have done this outer check here because the check is happening inside, because this is not a cast that we did. So we don't really need to do that. My bad here. Control-A, Control-I. Let's build to see that we are building fine now. And let's run. It should say rectangle count is 2. The rectangles with this object name are 2 rectangles. We have this one, and the others don't have that object name. You see we have 3 here and 4, so this is working correct. And I think we are also printing the colors, and they are here. The first one is green, the second one is blue. Let's bring this up, and this is green, blue. We are going to capture this color and do something based on the color of the rectangle. How do we do that? We are going to capture a Q variant, say var color, and it's going to be equal to item property color. We want to turn this into a Q color that we can parse for red, green, and blue components. The way we do that, we do Q color equals var color value, and we say that we want a Q color, and we put in our parentheses like this. This is going to give us the color that we can parse. We can actually test to see that we have the color components, Control-A, Control-I to align, by running the application and printing the color components like this. The red component, the green component, and the blue component. Let's run, and you see the color components are red, green, blue. Green is 128. And the second color is green, and the component for green is 255. Now that we have the color components here, we can actually do something based on these values here. Let's go down here and set some properties based on the color components that we have in here. If the green component is greater than 0, we are going to set the radius for the item. And if the blue component is greater than 0, we are going to set the height property to 200. I want to bring up the application to see what we have now. If we run it, because the green component is going to be greater than 0 on the green rectangle, it's going to have rounded borders because the radius is going to change to this value. And for the blue rectangle, because the blue component is greater than 0, obviously, we are going to change its height to something greater than what it is now. Let's run the application and see what we have. And you see that the green rectangle changes and the height of the blue rectangle is changing. Our changes here are affecting what we are seeing in QML. I hope this shows you that you really have some power over your QML in C++. We're going to go down below this block here and keep playing with our QML. What we want to do is to change the text that we see inside here from C++. So it is no longer going to say some QML text. It is going to say something we are going to specify here. I am going to put in some code to do what we want. It is doing nothing special really. It is just capturing the text item by its object name. And if we go there, it is going to have its object name right here. It is the same thing we have in C++. Now that we have this, we can actually say quick item set property. We are going to change the text. Let's just say text from C++. This is going to do. Let's run the application and see what we have. Expected a semicolon at the end. Let's run. It should say text from C++ now, and this is fine. You see that you can manipulate the text item from C++. Let's go down. The last thing I want you to see in this lecture is the difference between the two ways we saw to set the properties. We are going to grab the third rectangle here, this one. We are going to go back to C++ and capture it like this. And we want to see that we found the item. We're going to say f green rect. We are practicing safe programming here. We want to say green rect. Set property. The property we want to set is the width. And the value we want to pass in is, let's say 150. This is going to do. I want you to see that this is not going to break the binding that we have here. Let's run. If we click on the beige rectangle, you're going to see that the binding is still there. We're going to change the way we set the property right here. I'm going to comment this out. And we are going to use the other way we saw. We are going to say QML property, right? And you see that it is not recognized here. We should include that to the top. QML property. Let's go down and finish what we had to do. Let's say right. And we should specify green rect as our object. The property we want to change is width. And the value that we want to pass in is 150. Let's put a semicolon, run the application. Okay, we see our setting here. But if we click on the beige rectangle, the beige rectangle changes the width, but the other rectangle is not following, meaning that we have broken the binding by setting a property like this. And this is really the difference between these two ways to set the property. The second one breaks the binding, and the first one here doesn't break the binding. So you should be aware of the effects of these things as you use them in your QML applications. This is really all we had to say in this lecture. The main point was to show you that you can use QML application engine to load your QML file as an application. And we did the usual thing, which is capturing the root object and using that to parse everything we have in the QML file. We also had a chance to see that one of the ways we use to set the properties breaks the binding and the other one doesn't break the binding. In the next lecture, we're going to see how you can call a QML function from C++, which happens not to be at the root level. I'll see you in the next lecture. In this lecture, we're going to revisit how to call QML methods from C++. We have seen before, but what we saw was the case where this function was at the root level. So we didn't really need to parse through the QML tree to go and find the item that is buried deep into the QML tree. This is what we are going to do now. You see that our function is in this item here, which has an object name of deep2. We are going to dig and find it and call this function here from C++. So how do we do it? This is the C++ code. We are finding the root object, the usual thing really. We are finding the item that contains our function. And you notice that its object name was deep2 here. We get it. If we get it, we are going to do the preparation to call our QML function. This is the usual thing we have done. The only difference is that we are specifying the context, which is the object pointer to the item that contains our QML function. This is really all you have to do now. You find the item that contains your QML function in C++, and then you specify it as the context here. The rest is really the same. You specify the name of the JavaScript function, you specify the return arguments, and you specify the parameters that you want to pass them. And the return value is going to be stored in your return value variant here. And if you want, you can access it or do anything you want with it. We're going to go to Qt Creator and play with us. Here we are in Qt Creator. We're going to create our new project. It's going to be a Qt Quick application. It's going to say invoke QML method demo. Save it in a given location on your drive. Choose the Qt version you want to use. Choose the kit and finish. The first thing we want to do is to put in the QML file that we are going to use. It really is nothing special. We have a window here. Inside we have nothing visual. It is just a bunch of items. The first one has this object name. The second one has this object name. And it happens to contain this QML function. It has this parameter and it returns this piece of text here. It's going to console log to say that it was called, saying the parameter that we passed in, and this is what we are going to return to C++. What we have to do now is go back to C++ and call this method from here. First thing we need to do is to capture the root object and the object that contains our function. Its object name is div2. If you go back to QML, you're going to find it right here. And all we have to do now is figure out a way to call the method, passing in this context here. It really is the same thing we've done before. So we're going to test to see if we get a valid object and go inside here. We are going to say that we found the object, prepare the variant that is going to contain our return value, and put together our parameter that we are going to pass to QML. And the next thing is really going to fire the call to the JavaScript function from C++, and you already know how to do this. You do QMetaObject and call the static method that is called invoke method. You pass in the context that contains your QML function. We say the name of the function, we say the return value, and the argument that we are passing in, which is this one here. This is how you call the method. But we also want to capture the return value. The return value is going to be stored in this variant, so you can easily output it by saying qdebug. This is C++ return value s, and we pass it in here. We're going to say return value to string because it's going to be a Q variant. If we run the application right now, we're going to directly call this method, and we are going to get a return value. And the return value, let's go back to QML and say it is going to be return value from QML. Let's run the application, and hopefully it's all going to work out. We used qdebug without importing it here, so sorry again for this. Qdebug. Let's run again. And you see the return value is return value from QML. We are able to call a QML JavaScript function right here from C++, and the syntax to do that is this one. The takeaway from this lecture is really that to call a QML function that is buried deep down in the QML tree, what you have to do is to find the parent item to that function, and it happens to be this one. You have to give it an object name, and you're going to hunt for that object name and find the QML item that contains your function. And all you have to do is call it like this, passing in your object that contains your function. This is really all you have to do to get this working. In the next lecture, we're going to see how you can connect a QML signal to a C++ slot. I'll see you in the next lecture. In this lecture, we're going to see how you can respond to a QML signal in C++. This is what we are going to have. We are going to have a QML file. And if you go down here, you see that we are declaring our signal. And when the user clicks on this button here, we are going to emit the signal. This signal is special in that it is passing a payload to C++. And this payload happens to be this Q object that we are defining here. So we are going to see how we can use this to pass data to C++ if you happen to need that in your application. On the C++ side, we are just going to capture the root object. The root object is going to be containing our signal, so we're not going to do anything special here. We are going to connect the signal from the root object to a slot that we are going to define in our custom class. And inside the slot, we are going to capture the data. We capture the message that was sent, which is a string here. We're going to have it in the first parameter here. And we capture the second parameter, which is a Q variant. We're going to need to turn this into a Q object pointer, and we do that right here. And then we read the property from there. And the key is going to come from QML. It is this one here, mprop. And you see that it is what we are reading here. It really is easy to do. All you need is how to connect the things together. And we're going to go to Qt Creator and show you exactly how you can do that. Here we are in Qt Creator. We're going to create our project as usual. It's going to be a Qt Quick application. We're going to call it QML Signal CPP slot demo. We save it in a location on our drive, hit next. Choose the Qt version we have installed, choose the kit we want to use, and finish. We want to create a class that is going to wrap around our initialization here because we're going to need it in a minute. So let's add it. We're going to add a new class. It's going to be called AppWrapper. It's going to inherit QObject, not QWidget. Let's remove this. Hit next and finish. We are going to put in our initialize method. We want to include QQML application engine and define an instance of it in the private section of our class. Let's say QQML application engine and say mengine. Since we're here, we should also provide our slot that is going to respond to our QML signal. The slot is going to say void respond to click. The first parameter is going to be a string, so we're going to say qstring msg for the message. And the second parameter is going to be a Q variant, so we're going to say const Q variant reference, and it's going to be object here. We want to implement these methods as usual, nothing special here. And we want to take the logic to initialize our application from main here. I want to copy this and comment this out. Go to AppWrapper and paste this in here and adapt it to use mengine. We need to remove this, and it's going to say mengine. And here we should say mengine. And return false here if we fail. And if we get down here, we should return true, meaning that our setup here worked correctly the way we want. We can now go to main and actually include AppWrapper. Wrapper like this. Create an object of AppWrapper. Let's call this wrapper. And we should say if not wrapper initialize, we return -1. Let's try and run the application and see that we see the window. If we don't, we're going to figure out the problem and fix it. This is working nice. We can actually take this out and delete it because it is useless now. Okay, now we move on to the meat of this application. We go to QML and put in the code that we are going to use. QML is really nothing complicated. We're going to have our QML file in here. We have a signal that we have defined. A signal is going to take a parameter that is a string, and another is going to be a variant. We create our object here. It has an ID, payload, and we define a property inside just to show you that you can pass it over to C++ and be able to read this property there. We have a button that is going to emit the signal. It has a text property. It has an object name. We don't really need this object name because all we want is to capture this signal, but we leave it in here anyway. We have an onClicked signal handler, and in here we are emitting our signal. The first parameter is the string, and the second one is this payload here. Nothing special. What we want to do is come to C++ and capture the root object. We capture it down here when everything is all right. Once we have the root object, we want to connect the signal from QML to this slot here. And one thing you should notice is that the parameters have to match. You see, we have a string and a variant. On the C++ side, we have a Q string and a Q variant. So they have to kind of match. We're going to say connect. We're going to say root object, signal. We're going to see that the signal is not going to be recognized in Qt Creator. So we're going to have to type it out ourselves. We're going to find it in QML. We're going to copy it and put it in C++ here. We're going to say QML signal. It's going to have two parameters, Q string and Q variant. And let's check the bounds of our signal. We want to connect it to a slot that is in this object, and we're going to say respond to click. And just like this, we have connected our signal to our slot. We want to do something in the slot. The first thing we want to do is to debug output this message to show that we just captured it. We're going to include qdebug and say qdebug here, msg, just like this. And we want to capture this object here. Notice that we have a Q variant. We want to turn this into a Q object pointer. We're going to say Q object pointer object equals object value. We want to specify the type of the value that we want. It is going to be Q object pointer, and put a bunch of parentheses just like this. And this is going to give us our pointer. Now what we can do, we can say qdebug and read some properties from our object. We're going to say the property as, we're going to say object property. Let's find the key we want to use here. It is going to be mprop. Let's copy it, put it in here, and say toString, because that's what we need here. Let's build the application and see that we have no boo-boos. What is this thing here? We named these two things to be the same. I really should have done mObject and used mObject here. This should take care of my mess here. Let's try and build again. Hopefully it is going to work. Okay, we are building fine. Let's run the application. We have the button here. So what is going to happen when we click on this button? What we expect is to fire this signal, which is going to pass in the message, which is going to be QML parameter. We also pass in this payload. In C++, we are going to capture this because we connected the signal to this custom slot that we have in here. And we're going to capture the first parameter, print it here, turn this object reference into an object pointer from which we can read the properties like this. Let's bring the application up again. Click, you see the messages QML parameter. The property is QML payload data. And if you go back to QML, you're going to see that this is exactly what we put in this property. We are able to send a signal from QML with a payload, and you can really put in as many properties as you want in here. It really is a matter of what you need in your project. We are going to stop here. In the next lecture, we're going to try and review what we saw in the chapter and make you aware again of your new gained powers. I'll see you in the next lecture. I'd like to congratulate you again on finishing a chapter of the course, and this one is special because it is the last one. Before we do anything, I'd like to remind you that what we saw in this chapter should really be used when you need to, because it is not recommended for your C++ side to know that much information about QML. It is not a good design to have your application depend on the structure of your QML file. Again, the Qt documentation is trying to warn you. You can go to the documentation and read this again. You should really do this when there is a good reason to do so, because it is going to break the maintainability of your application. Now that this is out of the way, we started the chapter by showing you how you can load a QML file using QML engine. And what we saw really boils down to a few steps. You get the root object that is wrapping around your QML file, and you can parse it using the findChild method or the findChildren method and find what you want based on the object name that you pass in. Once you have the object, you can read properties or you can write properties. We saw a lot of this. Next, we saw how you can parse your own custom type from QML. We read the football team class and we were able to read the properties from the class in C++. We also saw how we can use QQuickView to display some visual components in our QML file and looked at how we can manipulate the QML from C++. We moved one level up and showed you how you can do the same using the QML application engine class, and we were able to show the difference between the two ways we saw to write properties. We saw that one was able to break the bindings that you have in the QML file, and the other did not break the binding. We showed you how you can call a QML method from C++, and the important thing here was that you had to dig through QML and find the QML item that contains your JavaScript function. Once you have it, you really have to specify that object when you call your JavaScript in C++. And we saw exactly how to do that. We closed the chapter by showing you how you can connect a QML signal to a C++ slot and be able to pass objects that contain a bunch of properties inside. We were able to read these properties from C++ and display them with QDebug. This is really what the chapter was all about. I hope it was informative to you. In the next one, we're going to see some things you can look at to spice up your powers of interfacing Qt to Qt C++. I'll see you in the next chapter. I hate to say it, but we are at the last lecture of the course. The course was all about some of the advanced features when you are interfacing your C++ to QML. We took a detailed view at how you can build your custom C++ models. And this is a very interesting topic in my opinion. You're going to need this a lot if you are designing some serious application. We also looked at how you can design your own visual types from C++ and use them in QML. We looked at some of the features that are at your disposal if you want to expose your C++ types as singleton for use in QML. We closed the course by digging deep in QML and showing you how you can read properties, write properties, and really manipulate your QML from C++. We also gave you a clear warning that digging QML from C++ is not the recommended way to write your Qt applications. But if you happen to need this, you might have a good reason to do that. The facility is there for you to take advantage of. Okay, now you really have a good package of knowledge that is going to help you take advantage of what Qt has to offer and use the powerful features that are available on C++. In terms of what you can do next to improve your knowledge, there isn't really much I could tell you to do. If you want to push further, you just have to build projects and try to use the features that we talked about in the course. You can search on the web and find some projects that you might be interested in. You can go to GitHub, search for the QML keyword, and you're going to find some cool projects where you can use your new gained powers. Another thing that is going to help you a lot is the Qt documentation. It is really great. You can learn tons and tons of things. There are examples you can take advantage of. So when you are in need of a feature, do use these things and you're going to find things and learn more things that I could even talk about in the course. This brings us to the end of the course. I'd like to thank you for enrolling. If you like the course, please do consider leaving a review. But most importantly, I am wishing you well on your journey as a Qt developer. Till next time, bye.